Good morning. This is Tom Gardner representing the Computer History Museum. We're here in the offices of Awita Venture Capital in Superior, Colorado, to talk to Peter Groel. Peter is a executive from the tape industry, started as a working engineer, and then wound up heavily involved in the OEM side of the tape industry. Peter, tell us about your background, where you came from.
I was born in Germany, that's where my accent is coming from, in a small village called Kinsbach, which is south of Frankfurt. It is very close to Ramstein Air Force Base and to the big American military hospital in Landstuhl. So when I grew up, there was all the military around flying the fighter planes at that time. The fighter planes are now gone. It's just transport planes for the supply route to Iraq and Afghanistan. That goes all through Ramstein, and Ramstein is expanding. When I was, I think, about 4 or 5 years old, my parents decided to build a house. So they did that with the help of neighbors and friends mostly, and they built that house, and then they did what most Germans did. They rent the rooms to American GIs. American GIs were allowed to live off base if they were married. And they really wanted to get off their housing in the base. They didn't like that. So it was not a problem finding somebody to rent your space. They stayed for a while, then they got transferred, so they left, and the next family came in. I grew up playing with American children, and I didn't speak any English, they didn't speak any German, but we still got along just fine. That was quite a while ago, and with 2 of the families who stayed with my parents, I'm still in contact. One is more I have a sister that's 4 years older, she does most of them, but the other family, Marja and Arnie, we visit regularly, do the Christmas cards and these things, and what had never occurred to me, how young these people were when they were with my parents. To me, they were adults. I was 7 years old maybe at that time, and then I found out Marja was barely 18 when she came. She was from a little town, Nauvoo in Illinois, and lived on a farm. The first time she left the state was to come to Germany. And she was a little bit lost, like the other one. So my mother did the mother role for all these women and helped them to do whatever they needed to be doing and made them feel welcomed, and their parents wrote to her how happy they are that they found somebody to help them. And for me it was a different world because Americans had things we never seen, ice cream and chocolate and candy, and at that time we didn't have it. Either it didn't exist or my parents would never spend any money on something frivolous like that.
So what year were you born?
51.
So this would be late 50s.
Late 50s, around
into
that
the 60s.
time, yeah. Things got much better. For my sister, who's 4 years older, it was a little bit a tougher time where nothing was there. We certainly had enough food and these things. You just didn't spend any money on things you had to buy. You grew your own food mostly. We lived what we had in the garden, more or less, and you bought what you had to.
Did you learn some English in your dealing with the youngsters?
I may have learned 3-4 words to do it. Yeah. A little bit more when I got older in school. Of course, we had English. When I was early teenager, I started to play with some electronic components, and the first radio I put together had maybe a handful of components. No amplification whatsoever. You had to listen to an earpiece, and the only station I could get was AFN, American Forces Network, and they had great music, the rock music the German stations didn't play. So I had a great time listening to that. Much later, I got a TV to work, and I got the AFN TV station. And I remember looking at things and I couldn't figure out what was going on. Later I figured out I was watching General Hospital, soap opera, and I did not understand what was going on, so my English wasn't good enough. But I watched Bonanza, it's a Western show, and I got some of that. It wasn't so much talking, but that was my upbringing.
Were your parents from that town, or did they move to that town?
My mother was from that town, my dad was from Landstuhl, which is 2 miles away.
Okay.
And he was in the war in France as a ground support to Air Force. And after the war, he was for a little bit prisoner of war, but then he left and went back to Germany. It wasn't like they were incarcerated or anything. They just were in France working somewhere, and if they didn't like it anymore, they just left when it was time to go home. So he came back, and then he worked in the equivalent of the IIS in Germany, Finanzamt.
The IIS?
IIS, the Internal Revenue Service,
Gotcha.
taxes, that type. So,
So did you go to high school in that area?
pardon me?
Did you go to high school in that area?
Yeah, well, German school system is there are 9 years mandatory school, and this you have to do. So everybody goes to the same school. After 4 years, you have to make a decision. Stay with that school and finish your 9 years. At that time, after you finish it, you typically become an apprentice. You learn a craft, you become a plumber, baker, carpenter, that type of things. You go to formal apprenticeship. Or if you exit after 4 years, you go to a different school, which is the preparation for university. That allows you to go to the university. And that it depends a little bit where it is. It's a bit different from state to state, but that secondary school after the 4 years is typically another 9 years, at least at my time. It was another 9 years you go to that one, and after that one you can go to the universities.
And that's what you did?
Yeah, with a little bit of detour in between, but that's essentially what I did. And then I went to engineering school, which at that time was no problem getting in. I don't know if it is any more difficult. It got a little bit more difficult getting into the school, and there is a numbering system with your grades going, how much you weigh, military service, all of that, and eventually you get into that school.
Which engineering school did you go to?
I went to engineering school in Mannheim, and I was working on my degree was in electrical communication. And there is no tuition in Germany. All of these are free. But I worked all the time I needed a place to live, I needed some food and so. So during that time, I worked the entire time. So going through that school took me about 4.5 years. It's 8 semesters mandatory.
Was it a technical Hochschule, or was it just?
Yeah, that's what technical high school you would call it, but it's not quite a high school like it is here. It's more like a university type thing.
Yes, I had mentioned I spent 2 years in Darmstadt, which also has a technical Hochschule.
And Darmstadt is a big one, yeah.
I was just out of the university myself as a young engineer. I met a lot of people at the technical Hochschule in Darmstadt. So what was the name of the preparatory school prior to the Mannheim Technical Hochschule? Did it have a name, or was it a city?
We call it Gymnasium.
Gymnasium?
Gymnasium.
And was it a gymnasium in a city? Or?
It was in the village next to it, in Landstuhl.
Oh.
Kinsbach was too small for it.
Okay.
Landstuhl had one. It was pretty easy to get there. You took a bus and got there for the couple miles, and if there was no bus, you walked.
So you went to the Landstuhl Gymnasium, and then on to the engineering school, the technical
engineering school
Hochschule.
to doing that, I didn't like the schools. I didn't like memorizing things. I hated languages. I wasn't a very good student until I made it to the engineering school, and that I liked. That was fun. And I started to become more lively in it, and it wasn't a problem for me to do the engineering school, because it was a fun thing to do, and I really wanted to do that. The other schools were tough for me.
And by that time, your English was getting better, or were you still?
No, it wasn't really good. In the school, yeah, you have to study. English is one of the languages that is mandatory. I don't think, maybe in the Saarland, which is close to France, you can select French as a first language, but we couldn't. You had to have at least one, or I think I had to have 2 languages. And they teach you English, but you don't speak it. You read text, you read Shakespeare, you read many different things, but you don't speak it. So I hardly knew English. You can read it a little bit, but not very well. You cannot do a conversation. You can say a few things, but conversations, nah, probably not. And I wasn't good at it. My sisters were much better at that stuff. They were all into the languages, these things, but I was going to stay out of it.
How many siblings do you have?
I have 2 sisters.
2 sisters?
One is 4 years older, and the other one's 9 years younger, and they both still live in Germany. And that is my connection to Germany, so once in a while I go to visit or they come here.
So now you're a fresh university graduate.
I'm a fresh university graduate. In the last couple semesters, I got to work on some fun stuff in the university, and one of the things was some programming. And I remember my first time I saw tape. It was paper tape with holes punched in, optically read. That was the data storage at that time.
Let me just back up. Why did you choose to go to the Technische Hochschule?
I liked playing with electronics.
Okay.
I liked the engineering stuff. I liked physics. I liked math. They would have thrown me out of gymnasium because I was bad in languages if I didn't make up for it with physics and math and these things. That's what I wanted to do.
Okay.
In the engineering school, they told you don't have to memorize anything. And the professors were actually proud of it, saying, we don't know facts. We don't teach facts here. You can look up facts. You need to understand things. Try to understand and don't memorize. And I said, I'm going to love it here. I hated memorization. So that's great, and that's what it was.
Okay, so you had mentioned your first storage item you saw was paper tape.
It's paper tape, yeah. That's what we used to store our programs on. We had strips of paper, must have been about ½ inch wide around there, with I think 5 or 6 holes in a row, punch thing, and it could read and optically read those. That was my first tape I ever saw.
Yeah, I think they probably first read with pins that went through the holes.
Yeah.
Some may have been optical, but my first
those with fingers.
fingers, yeah, my first storage medium was also paper tape.
Paper tape, yeah. Same story. When I was done with the engineering school, they had engineering school, all these organizations, engineering organizations come and talk to you what to do for it. And the advice was go to a big company. If you want to go to a small company, you always can go from the big company to the small company. From the small to the big one is much, much tougher. They don't know who they are. It's difficult. So I said, okay, big company. And then when you were done and you looked for a job, all you had to do is give these organizations your name, and they published it. And at that time, the companies pursued you. Paid your travel to come and visit, showed you around, showed you the city, tried to convince you to sign up with them. And I did it in maybe 5, 6 companies. And I selected Siemens because Siemens certainly is a big company. They at that time had over 400,000 people. It's probably still that size. And they were in Munich. And I liked Munich. I wanted to be in a city. I didn't want to go into little villages. I wanted to be in the city, and Munich is a great city. So that was part of going to Siemens. The fact that I started in a tape division made no difference to me at that time. Would have taken different things to become the unique. I'm sold.
And that was what year?
That was in '74 when I started then with Siemens. End of '74, October with '74. And with Siemens, once you start there, the first year, you don't do very much. They send you to Siemens school. These were 4, 6 weeks classes, several. In between, you go back to where you were working, but you had a week between, then the next one started. So the first year was pretty much staying up, going to Siemens school, and not much work.
What did they teach at Siemens school?
Their products, how they work, how their processes work, how Siemens is structured. They sent me to English school. You got to know English, you got to be able to read in English, so you go to English school. Things like that.
Things like that.
Yeah.
So you actually went to a school to learn about the tape drives in the division you're in, or is it more general about all of Siemens products?
Both.
Both.
They had classes of how does a tape drive work? How do we do magnetic recording? And then was how does our specific product work, where we went through the schematics, what does this do, what's going on here? And then you had more information about a product. And for that one, I had selected many of the tape drive classes. So I did those, and my boss thought I should know more than that, so they sent me to processors, what Siemens processors worked, how they worked. So they sent me to these classes too. And that took up pretty much the first year. And they won't let you work during that time, because that is an earned right. It's not, we don't let anybody work. And I didn't know any better. And Siemens is a huge bureaucratic organization, and things moved very, very slowly. The most important thing for Siemens is the reputation of the company. We do anything to support that and nothing to endanger it. If we lose money, that's bad, but not as bad as losing the reputation. You don't do that. The product release took forever. You don't just ship a product. It has to get tested many, many times. It has to run internally, alerts. We have to prove that every piece of the product gets tested each time on power-up, during special test runs. All of that has to be proven. The documentation has to be just right. And Siemens sold their products always as a premium in Europe. They had that protected market. Nobody could go wrong buying Siemens. If you had a problem as a customer, Siemens took care of it, without a doubt.
Was that testing a separate independent organization from the organizations that developed the product, or how did that work? Who did the testing?
There were two. Once was the engineering testing. They developed the product and then tested it. Once engineering released it, then it went to the test facility, who started testing it with the different processors, CPU systems, with the different microcode versions, software versions. That was a long, long process to go through. And they complained about everything. They nitpicked everything. That was Siemens' way. They nitpicked everything.
My experience suggests that was also IBM's way.
Probably bigger companies could do that way. You know.
As opposed to today, where companies seem to put products out and fix the problems out in the field, or even discover the problems in the field.
Yeah, and sometimes these companies don't have much other choice, as I learned later.
And we will get to that.
At the startups, yeah. You are pushed into that position. It's nothing you can do about.
So now you're at the end of your first year.
I ended the first year and I got to do a few things. So I started to work in the tape drive business, the first tape drive. I still remember a 7-track tape drive. I didn't work on it other than adjusting that thing constantly. Everything was analog in there and it was always drifting all over the place. And that tape drive had 2 capstan motors spinning in opposite directions. Underneath the motors was a pinch roller on a solenoid. So when you want to go forward, you push that solenoid, the pinch roller, to the capstan, and if you want to go backward, the other way. And it made a really loud sound. Bang, bang, clack, clack. You hardly could stand being around that thing. And then I started to work a little bit on the 9-track NERSI units. It was Siemens product, entirely Siemens. They did that. And then the PE units is 3600, the 1600 BPI with phase encoding, and I did some of the electronics and that, the DSQ buffer, the signal processing, that type of things. A little bit later, we got involved with GCR came along. It had been in the US for a while, and Siemens eventually was convinced, yeah, that's a new generation GCR, we need to do GCR. At that time, StorageTek had already a GCR product. They were up and running, and they came to Siemens trying to sell their products to Siemens. And Siemens looked at that, yeah, we need to get into GCR, but we want to do our own tape drive. And we want to buy your controller. And StorageTek was happy to have Siemens as a customer. And Siemens can be quite tough in negotiating. So Siemens got that purchasing contract with StorageTek to buy the controller, but also at any time they wanted to get the right to manufacture that controller by themselves. Do a technology transfer for payment, and then they could do the controller by themselves. Siemens never quite intended to do that, but it was always there as a threat to keep the prices for the controllers in check. And I was at that time writing microcode for the tape drive. Siemens has developed the GCR tape drives, and we had to attach that one then to the StorageTek controller. So I started to work with the StorageTek controller for about a year or so.
Now at this time, you were changing the firmware in the StorageTek controller? No. So you had to adapt your machine to whatever the interface was from the StorageTek controller.
Yeah, and we had long lists of things we wanted StorageTek to change. And StorageTek did it in their own time, but they did it. Yeah, that system, we added some problem description to the list, sent it to StorageTek, we faxed it at that time, and kept that list and went through these lists once in a while, and StorageTek marked it off as solved one at a time, and I'm sure we drove them crazy. Some were real things, some was outright nitpicking.
My experience having designed disk drive subsystems is when you're interfacing to somebody else's equipment, you pretty quickly know more about it perhaps than the original designer, because they sometimes create things and don't understand the implications, whereas you looking at it from the outside realize that this maybe is a bug to be fixed, or this is maybe a feature not done well, or whatever. You understand more than the folks who originally built the product. Yeah,
you learn the idiosyncrasies, which they never saw, because they know what their tape drive is doing and designed it for that. That they had a bug in there which didn't show up with their tape drive, never came to their attention. And when we found it, we said it doesn't do that, it should do something differently, and eventually they changed it. So we did that for a while.
Now your tape drive, you said, was micro-programmed?
Kind of. Yeah, I wouldn't say it's a microprogrammer at that time. It was a kind of a hardware sequencer. In hindsight, it is like a microprogram, but there was no processor.
There was no...
No processor. Microprocessors didn't exist at that time.
You could build a processor out of
Yeah,
MSI.
Yeah, that's essentially what it was, but it was a hardware state machine. And it was programmed then like a program, which did different things at different times.
I don't think your competitors, I don't think StorageTek or IBM's tape drives were hardware sequenced. I could be wrong.
At some time they were not, maybe not in, by that time we are now in the N70s, mid to N70s.
I would have thought mid-70s.
Mid-70s, yeah, it was getting to the end of 70s at that time. Siemens is a little bit behind always with that. GZR tape drives were around here for quite a while. StorageTek had it, IBM had it for a while until Siemens moved over to do GZR. They could afford to be a little bit later in the market with that.
Yeah, but it's not a historically significant thing, but my understanding is the tape drives internally from IBM StorageTek were pretty, trying to come up with a word, they did not use microsequencers or firmware to control the functions. They were all analog or simple digital state machines.
Yeah.
And you know, now today everything's microprogrammed.
Yeah, it was, from what I remember, that interface, the signals were all analog. The head signals, there was an amplifier in it, we had some filtering in it, the amplifier, and that was analog. The command interface, what to do, that was digital.
Sure.
And that was with many different lines, and we processed it in our tape drive with a little state machine type things. It was early programming.
No, it may in fact be, it's certainly early, it may be one of the first, if not the first. I'm not that expert.
I'm not sure about the StorageTek tape drive. I think it was the 3600 series, from which we didn't use their tape drives. Maybe replaced that.
Do you recall the product number for the rebadged storage technology control unit and the Siemens
No, I don't
tape
know
drive?
anymore what Siemens called it at that time. But that was on the sales side. I didn't care much about that. And then in 78, Siemens said you need to go to the US to StorageTek for about 3 months, they told me. We need somebody on site there, so our problems and our issues we have getting processed faster, we need somebody to talk to them, and also if we take over the technology to build the controller ourselves, we need somebody there to get the technology, go through, make sure everything is okay, and to do that for us. We need to have somebody we can talk to directly, and do you want to do that? And I thought, oh, it's a great opportunity. I didn't think much, I'm there. So I came here to Louisville, Colorado. I stayed in Boulder and drove to Louisville to go to StorageTek. I never worked for StorageTek. I got paid by Siemens. I was a Siemens employee, just went to StorageTek and did that. And it didn't really keep me that busy doing that. So I had time to play around a bit. We played with the early versions of PCs, came along at that time. So some of my friends were there. Some of the people I knew, they worked for Fisk Planetarium in Boulder at the university, and we did that laser show with music things, and I helped with that thing in my spare time. That was all fun stuff to do. And then I went back to storage technology and talked to the engineer there and saw how an American company works. And I was in a complete culture shock. The autonomy, the authority of an engineer. They could decide things, what to do. They got to work on things. For Siemens, you don't just fix something. you have to get permission. Everything has to be in the proper channels. Here, engineers just could do things. And it was an entirely different world for me. I never had seen that. But I came from a very conservative German company to a very dynamic American company. It was a huge difference. I ended up staying just a bit over a year. After 3 months, Siemens said, I mean, another 3 months, another one. They probably knew it all along. They just didn't want to shock me with that.
Were you married at that time, or?
No, I wasn't married. So for me, it was no problem just to stay here and do that. And then came the time to go back to Siemens, and I was a little bit regretful going back home. And when I was back at Siemens, I got a second culture shock. I said, I'm dying here. I can't do that. I need to get out of here. So I went to my boss, said, I need to get out of here. And they were, well, yeah, do what you need to be doing. I said, I'm going back to USA to do it. And they were, well, if you ever want to come back to Siemens, it will be good that you did that. Foreign country experience, especially independent ones, not with Siemens, helps your career. They were all thinking career-wise, getting into management. That's what Siemens wanted me to do. Get into middle management, go into the management route, and I never wanted to do that. I wanted to play with things. Management sounded incredibly boring to me. I wanted to build things, make something work, that type things, and that was tough to do at Siemens.
Any interesting experiences when you were interfacing between Siemens and StorageTek in that year? Any interesting problems or anything comes up that this discussion sparks your memory?
I remember what we talked about, the problems they had and the reaction to it. Storage technology was very professional about it, even though we were nitpicking stuff and giving them a hard time about everything. Archibald was his name, who was my guy at StorageTek. I talked to him going through the list.
Say that name again.
Archibald.
Archibald?
Yeah, I forgot his last name.
His first name?
Yeah, I think it was either his first or last name. I forgot that. I always talked to him. And I could tell at times when I had to tell him a new problem that his temperature was going up a little bit and saying, okay, he's going to blow. When I tell him there is a typo in the documentation somewhere and it needs to be fixed and things like that, or the color of a wire was wrong, it should be a different color for whatever reason. And I think he blew up a couple of times, but for most time, he could keep it nicely and quietly. The real problems we had were some of the signal processing was a little bit off. They wanted to be processed differently. The error rates were too high, they thought, and it was a bit, well, in our tape drive it isn't that high. So it must be a tape drive, not our controller. And that went a little bit back and forth where we went through. Eventually, we did the engineering thing. We sat down and said, okay, let's go through that. And we did it, and we resolved it the engineering way and kept it out of that management things. With the engineers, I had always a great time. You showed them a problem, they said, oh yeah, there is a problem, let's fix that. With the management, it got a little bit differently.
At that time, I think the interface, the data interfaces were still analog, if I'm not correct.
That
Right,
was
so
the signal interface was
basically
all
you're sending an amplified head signal.
Yeah, it was amplified and filtered a bit.
But it's purely
we did
analog.
some processing on it, analog processing on it to clean it up a bit, to send it there. And we went through the error rates and saying, well, we want lower error rates. Some of it was because Siemens just wants lower error rate on anything. To saying we can't have that. It was a different threshold of requirements. Some was that the signal looked somewhat different than from StorageTek signal. You process one signal differently than the other one. So then it was with two changes, yes.
So our discussion with Oeda yesterday, he pointed out that one of storage technology's advantages was that they had some form of automatic gain control in their drives that IBM did not have, and therefore they could read tape that IBM could not read because the AGC would bring the signal up to the point. And if you didn't have AGC, then the error rates would be dramatically different.
Oh yeah, we didn't have AGC at that time. We found it out. I found it out, and talking to the engineers, they talked about the AGC and talked to Siemens about it, and Siemens was, well, maybe we'll look into it, but just doing something that will take a while.
Well, that's one of those examples of where your drive is different.
Yeah.
And it's trying to talk to the same controller. And they could do things perhaps, but fundamentally, you're going to have a different error rate.
Yeah. And the only way you can do it at all, at least at that time, was because StorageTek was supportive to do it. You could not just say we make a tape drive which we attach to the StorageTek controller and off we go. It would have never worked. You had to have the full support, and which was there because of that purchasing agreement.
AGC is a big thing, and there must have been 1,000 little things that made your job and Archibald's quite interesting.
It was interesting job to do it. But it wasn't that difficult to do it at that time. You had that list of problems and you went through and you solved each one as an engineering way. And with StorageTek being supportive, it wasn't that difficult to do.
In retrospect, do you or did Siemens management realize that, or even understand that putting you or their representative in StorageTek would in fact facilitate the correction of those problems? Did that work? Was that a good deal for StorageTek or for Siemens that they sent you there? Did that really?
The reason they really sent me there to keep up the fiction that they would at some point manufacture that controller by themselves and get a good price of the StorageTek equipment. They got a lot more information, a lot more out of it than they thought they would. Mm-hmm. But if they realize that, well, that's Siemens.
Hmm. Did they replace you?
No.
So it was 1 year and then?
That was it.
That was it.
That was it. At that time, Siemens started to do their own controller, their own development, a different tape drive, a different system, and they eventually did that. Mm-hmm. I saw an article just recently, came up on the internet from '84, at the time when I was here, when Siemens was shipping the smaller tape drive that had that quad density in it, which means they had to know GPE, double PE, and GCR. And so they did their own controller. At that one, it was a self-loading one. You push the tape in, it spins around, the airflow threads it, and there's that. And at that time, they sold that thing for almost $50,000, which would be now over $100,000. Were here at the same time, these things sold for $10,000. It's at that time, so it would be $20,000 now. So this was quite a huge price difference what Siemens was selling for than what anybody else was selling for in the world, but that was Siemens.
I think storage technology and IBM's prices for tape drives were higher than $10,000.
Oh yeah, but that was not the little ones. Okay. These were the big refrigerator size units.
Right.
Yeah, they were 30, around there.
Yeah. Okay.
Yeah. So I decided I couldn't really be at Siemens anymore. And I needed to do something. And I wanted to come back to the area where I was happy. I loved Boulder. And I saw all this dynamic here for engineers, what they could do, what they develop. So I try it, I give it a try. Then I went through immigration, which at that time, that was before 80, that was 79 by now. We are. That wasn't a problem. It went really fast and easily. In hindsight, they looked for two things. Are you going to cause us a problem in a legal way, criminal activity? Or next thing was, are you going to come because you want to take advantage of our welfare system? And if you want to take advantage of a welfare system going from Germany to the US, you are confused. You better stay where you are. And so they decided probably neither one of these were the case. And I think the guy spoke to me in English to make sure I had some rudimentary understanding of English. And I just came back from a year there, so they gave it to me. It was easy, fast. Then I came here. I was on my own, got an apartment somewhere, and started to look around for a job. And at that time, it wasn't that difficult. So I found a company called NBI. That was in 1980.
Did you talk to Storage Technology?
Yes, I did, just to tell them I was in the area. Thank you for your time, but I couldn't go to StorageTek. I was at the other side. Now going to StorageTek at this side, it would have seemed wrong. Completely wrong. Maybe StorageTek wouldn't have mind, but Siemens certainly would say, you can't do that. No, I said no. But I went there to saying, hey guys, I just want to come to say hi, I'm in this area, and if you need something, give me a call, that's where I am. And we talked a little bit, and maybe we talked a little bit about what StorageTek was doing, what openings they had, and I appreciated that whole thing, but no.
I think 1979 was probably a high point in storage technology. They had multiple different products being developed. The revenues were peaking, and
StorageTek was
it was a real. If you had shown an interest, they probably would have snapped you up. But
but it
but
wasn't
you
possible.
You weren't interested. You felt it would be improper.
I thought it would have been very, very improper, and Siemens would have thought it is improper to do that. You don't do that. So, and it wasn't that difficult to get a job. I had, within a couple of weeks, 2 or 3 offerings, and I went through, but I decided on NBI because they were relatively small at that time. I didn't know, at that time it didn't occur to me that the president at that time was Tom Kavanagh, who also had started storage technology, of course. He didn't start NBI, but he came in a little bit later and took it over. Big Selby started it much earlier in 75. And then I started with NBI, and they had a great product. That was a word processing equipment. And it replaced typewriters. The alternatives were typewriters. At that time, you still had these huge pools of people sitting there, women sitting there, listening to a recording and typing it per hand in to have a letter. And NBI built dedicated hardware to do word processing. And that equation editors, which was good. And the storage medium for that was 8-inch floppy disks. And now at this time, that was 1981 by now, we are into programming. That definitely was a microprocessor, I remember, it was that big. With many pins that big, I forgot, C80 or something like that it was called. So I got a job there to write microcode for the word processing equipment, the floppy disk interface, and just about everything there. A little bit later, NBI got what they called a hub, which was essentially a server for all the workstations attached to it. And then in later years, we developed a Windows system, and it was years before Microsoft did that. NBI could have been the next Microsoft, but they missed the boat. Yeah. when the PC came along, the engineers looked at it and said, maybe we should look at that some more. Management said, our business model is we make very expensive hardware, very solid, and we sell it to the Fortune 500. They sold it to the big guys. All the big guys use NBI equipment. The PC is a toy. We don't do that. A little bit later, the PC was start to spread out. Maybe we should have another look at it. Okay, we couldn't put our software into a PC, it wasn't powerful enough. We need to replace the hardware. After we were done replacing the hardware, we had built another NBI system. There wasn't anything left of the PC. We used maybe a keyboard or a monitor or something like that. So that route didn't work. So NBI, when I started in 81, had maybe about 100, 200, maybe more like 200 people. The vice president of engineering when I started was a guy named Bruce Holland. He left pretty soon after that and started a company called Catnetics. The same idea, you build dedicated hardware, and his software was doing PC board layouts. Became a big company eventually. After Bruce left, we got another vice president. His name was Carl Carmen. And he was good to work with, so I worked with Carl Carmen at NBI a little bit.
You spell that last name?
Carmen, Carl Carmen.
K or C-A-R-M-E-N?
C, with C. C-A-R-L-C-A-R-M-E-N, Carmen. And I met Carl in different capacities later. And NBI was getting bigger and bigger, and then we moved to our own buildings, 3 big buildings north side of Boulder, the diagonal next to the airport. And then these buildings were not big enough, so we moved next to a brewery and rented some space there and worked there. And then the PC came in full force. And NBI went downhill fast. 2 years later, there were all these waves of layoffs. And 2 years later, there were maybe 30, 50 people left, and I was still there. So it's time that you do something. One of these layoffs will get you. There's almost nobody left. So then that was then in 85, meanwhile. I heard of a company in Longmont, Aspen Peripherals, doing tape drive related things. So I went to Aspen, interviewed there, and then got a job to write microcode for a tape drive. It was a 3480 compatible tape drive, IBM 3480 compatible. Ran Vitullo had started the company. He came from StorageTek. Just about everybody there came at one point, worked at StorageTek. And we did the tape drive. Didn't do the controller at that time. The idea was you get IBM's controller and we attach our tape drive to IBM's controller. And IBM controller, I think, supported 8 tape drives. So you had controller, 8 tape drives. They're all relatively large pieces of equipment. So you do that. And said, oh, that's going to be difficult. But no, that's going to work. I said, okay, fine. So I started to program on that thing, attaching it to the IBM controller, and we had all kinds of problems with that. Eventually, the company decided, yeah, we need to do our own controller. By that time, we were microcode controlled, everything. And we soon found out we had a sensitivity to the microcode level of IBM. With one level, you worked perfect. The next level, it didn't work at all. And you can't have that for very long. So the company started developing it. I was in the lab working, Carl Carmen showed back up. Hey, how's it going? Where are you? He was one of the investors into Aspen, one of the main investors. Carmen Hill, Washington was the company. They had an office in Boulder, a former schoolhouse, beautifully renovated. It was a great place. So he came. He wanted to talk to the engineers. He thought he'd get a bit more better information than going through management and getting the filtered version. But at that time, it started out with the VCs that you got pushed into product releases. They were looking for the exit strategy. Where are we going? We need to get out with the products. We need to do it, and it was nowhere ready. I always thought, you are not ready for that. Siemens would have never released that. It would have taken years to do it, but you don't have years. You have to do it. So we got out to a couple of customer side, and at that time still with the IBM controller, and we had all kinds of problems which we fixed in the field, one after another, to do that and replacing it. And the VCs got more and more impatient, so they decided it was management's fault and pushed Ranvi Tuller out and got a guy named Don Lundell to run Aspen. And he didn't come with the tape drive or technology background. He had essentially business, I forgot what he did, but he had no idea what a tape drive was. Ranvi Tuller was the happiest if he could come in the lab and sit in front of a scope. Don Lundell didn't know what a scope was. He was completely somewhere else. And he was at times a little bit difficult to work with because there was the friction that he didn't know what we were doing. He didn't quite understand it. You couldn't quite explain it right. Then the VCs hired that psychiatrist to come and talk to us to figure out why don't we work with them. And her answer was, nobody likes him. I said, well, we could have told you that. Then I don't think he was my boss at that time. Tony Murdian was one of the managers at Aspen, was a bit of a rebel. He later was my boss at that time. He decided the company is going downhill with Lundell. We cannot do that. And he had talked to the VCs before. They kind of listened and said, just try your best to work with them. So Tony got everybody together. The engineer said, we need to write our resignation because that's not working. So we did. We wrote a letter to Groel and told him, we are all resigning because the company is going to go downhill because of the management structure you put in place. And we gave it to his secretary. I think Groel was in the Bahamas sailing or something like that. That was on a Friday. The next Monday, Groel was back, fired Lundell. So he needed somebody else to run the company. We were working with Oveda Systems. They were the sales force, part of the sales force for Aspen. So they knew whom to get in place to run that. Then Jesse could do that. So that's how Jesse came to take over Aspen.
Oh, okay.
Through Oveda, he merged it with his company, the Salesforce company, into Aspen, and then Jesse was running Aspen. And Jesse had a clear vision what to do. He understood, he came around, asked us where we were, he understood that stuff, and had a very clear vision of where he wanted to go. He wanted to sell Aspen to StorageTek. That was his vision, and he did it. Before that, before Lundell came, Aspen had one opportunity like that to be sold to another company, and that was Siemens. Siemens came to look at the 3480 tape drive we were doing, and my old boss came, and some of his people came. About 4 or 5 people went through every aspect of the drive, the cost analysis, the cost structure, how did it work, and that team and the boss of that team made a very nice business case together for Siemens, saying this is going to be a success. You need to buy Aspen. We can manufacture then part of it in Germany at Siemens, and Aspen can still be in the US. And the business case said it would be a success for Siemens just based on Europe. Even if we don't get any sales from the US, we can make a success out of it. Whatever Aspen sells in the US is just gravy on top of it. And then a higher up killed it at Siemens. Didn't want to do it. I never liked that guy anyway who killed it. Would have been good for Siemens, would have been good for Aspen. It could have worked out just beautifully, but it didn't happen. And that whole effort died. Then then the merger happened with, let me see, the merger was a little bit later. That was 89. In May of 89, StorageTek took over Aspen Peripherals. Many of the people at Aspen didn't like that. They came from StorageTek, they didn't want to go back to StorageTek. It was the best thing for Aspen anybody could have done. It was really difficult to break into the OEM market with the product. They were more solid at this time, granted. There weren't many technical problems anymore. But how do you start selling against IBM directly head-to-head in the data market, in data centers? What we saw, I went to EDS in Plano, Texas, Russ Perot's old company. We had some problems there, where they had some of our tape drives, and they had a control unit, 6 IBM tape drives, 2 of Aspen's. And said, okay, why don't you do all Aspen's or all that? Like, well, we showed that to IBM. That's to keep IBM honest. We show IBM we have an alternative, so keep our prices down. And that's all that Aspen was for them. They had never any intention to buy in any quantity the Aspen machines. And they had hundreds of tape drives at that time. There were many, many around. And the same thing in other companies where we went, it was really difficult to break into that market, just about impossible. So all you could do is selling a company to a bigger one. And after Siemens didn't work out, StorageTek was the next best chance, and we talked about it at Aspen, and nobody knew how to do it, saying we cannot go to StorageTek. They may have talked a little bit to StorageTek. There was only one person who could do it, and that was Jesse, to go back to StorageTek and sell it. And it was mainly based on that Summit tape drive. We had the second generation. It was smaller, integrated controller, and that was what it was. StorageTek at that time was working at a similar tape drive, but Jesse thought that the Aspen tape drive was about 2 years ahead, and that what made the sale. That's how he sold it. The Aspen is 2 years ahead. You save 2 years, you get that market, and then StorageTek bought Aspen in '89.
So let's back up, and you've talked about 2 different products: the first generation and the second generation. What was the first generation product?
The first generation was a tape drive that just looked like IBM 3480. It was essentially a copy of IBM's 3480. Hydrostatic air bearings, a big pump for air pressure supply, big motors, big machine, and attached to first the IBM controller, and then later to an Aspen controller.
Now you said copy. There are degrees of copying.
It was a real close degree of copy. If there was anything in it we didn't understand why, we copied it. We put the same in it.
Same tape path, same...
Very similar tape paper. They called it scratch compatible, meaning if there was a scratch at the IBM reel and you didn't know why it was there, put it in.
This the same mechanism for winding, for feeding the tape?
Yeah. The same arm. It was an arm at that time. We got a hold of the puck in the beginning and pulled it through. It was very, very similar.
Okay.
Yeah.
Did Aspen must have bought its heads? Or did Aspen make its heads? Must have bought its heads.
No, we bought the heads.
From?
AMC, American Magnetics Corporation.
Yeah.
They made the heads at that time. No, we didn't make any heads. No.
So about the same size as the IBM 3480. I mean,
Yeah,
essentially,
the same. It was very much the same.
parts might even have been interchangeable.
Probably to some extent. After a while, it diverges a little bit. But yeah.
you know, the history in both the tape and the disk storage space is the term copy is used very loosely from something that's plug compatible,
Yeah.
and the IBM salesman calls it a copy,
Yeah.
even though not a single part is interchangeable.
Well, yeah.
And some other products where literally they are xerographic copies. I mean, the parts are almost interchangeable. Same term, and I was just curious. Aspen was had to be plug compatible because it worked with a IBM control unit.
Yeah.
But and in this case, it was a close copy.
It was a very close copy. And then the second generation was not a copy of anything. Nobody had that. It was a rack mountable 19-inch rack tape drive with a controller right next to it, attached to the tape drive. One compact unit, and the mechanics, the tape path was different. It was unique. Aspen was our own development. That at that time we had more freedom to do what we wanted to do. Now you understood the technology. Now you decided. Now we really do it. Yeah, and we were working on that one, and it had an autoloader, a 10 cartridge loader, and a magazine. So you could take the magazine out, put it in, and load all 10 out, and wrote the microcode for the autoloader at some point. Worked on that one, and tape drives in the tape drive. And that's what made the sale of Aspen to StorageTek possible.
On the theory that StorageTek had a similar product, but was years away.
Yeah, that was the theory. We didn't know at Aspen. We didn't much care what StorageTek was doing at that point. We may have known that they were developing something, but I certainly didn't know what they were developing. We just thought we need a new generation. The old one was too expensive to build, too clunky. The sales were horrible. We need a new product. And we went and developed a new product, and Chile was there at the end phase when we developed that.
Continuing with the first product, it had a name or a model number?
I think we called it 480. There was an i480 that may have been the controller, and the tape drive was 480 tape drive. Yeah, it was just called the 480 system. Okay. That is the first brochure. The big brochure, that is the 480 system.
And the market was who? Who did NBI, who did Aspen
sell to?
Sell to?
They want to sell data centers. That's where you had to sell to it, because they're expensive big machines. Okay. That's the only ones who could sell to is in competition to IBM into the data centers. Okay. And we sold locally, Lowry Air Force Base in Denver, an active base no planes landing there, but something to do with the Air Force. I remember going there at night fixing problems. You could work at night. You got there at night, I stayed all night to fix a problem, went back to Aspen in the morning, sat through the meetings, and then I had to do my work. And there were times when I was up at 80 hours a week for a while. It was a tough time, an exciting time, and it was very emotional for everybody there. We wanted to make that work. It had to work.
Selling to the data center is a difficult business.
Say the least, yes.
You need generally expensive salesmen. You need
knowledgeable
an extensive field service force to maintain it, and you need financing because most of the products are not sold, but they're rented or leased.
Yeah.
Did NBI?
Aspen?
Or Aspen, I'm sorry. Did Aspen have the wherewithal?
No. And not the financing from the VCs anymore. They wanted out. They wanted the exit strategy. They want to get out of that, getting the money back.
But even, could they even sell the product without the sales force? Could they, I mean, it's, as Jess said in his oral history and as other people have said in oral histories of Memorize, it's very difficult to sell on service and finance.
Oh, yeah.
And, you know, Aspen would have had to raise a lot of money
Yeah, which
to
they
be
didn't.
able to do that.
No. Some of it then Jesse did with the reader systems before the merger.
Okay,
Jesse had a sales force and service people, reader systems to do it. And Aspen was selling through Jesse.
okay, so,
Some, but not exclusively. We sold to other resellers too. And I was really busy trying to get the machines to work. I not that knowledgeable about the sales side. I just hoped it happened. And it didn't.
so in that time period on the first machine, you were working on issues on the drive side
On the drive
because,
side, yeah.
because the controller at that point was
IBM.
the IBM controller.
Yeah.
Any interesting experiences in that time frame that you recall?
They were all very interesting because they were all in the field and all under high pressure to get it done. We went to Plano, Texas, to Barrow's site, which was entirely different than what I've ever seen. He still had the wheel-to-wheel machines there, and people running around putting the tapes in it in suits and ties. That was Barrow's operation. I'd never seen something like that. We worked nights, so we didn't have to wear a suit and tie just to work there. Getting it to work, yeah, the biggest problem we always have was a microcode dependency. The level of microcode always changed in the IBM machine, and sometimes we were immune to a change, but sometimes you are not. And now you are back to figuring out what just changed. And then you try to make the equivalent change on your side. That's all you can do. We asked IBM, can you tell us how that interface works? And they said, no, we won't. Why would we? But we tried.
Do you think any of these changes were deliberate or were just accidental, inadvertent?
No, they didn't care about us. They didn't care about Aspen. They saw that they didn't. I don't think IBM ever saw Aspen as a threat. Didn't impede their sales at all. The fact that there were a few Aspen machines there to keep IBM honest, like they said, IBM would actually not mind that a lot. Then the customer feels they have an alternative. They stay with IBM anyway. The customer feels better. It's not a problem for IBM.
And by then, IBM was perhaps more flexible on pricing than they were 10 or 15 years prior. So, and Ross Perot could negotiate a price, maybe not directly, but across a whole spectrum.
Oh, yeah. We got good prices from IBM, and I'm sure IBM was still above the Aspen prices, but a customer would pay for that.
Okay.
To some extent. So it was a really difficult proposition to do that. A sale of a company could have happened, but not making it big. StorageTek pulled it off, yes, but nobody else ever did.
And there was really no OEM market for that product?
No, it didn't exist. Siemens could have pulled it off, but only because they have the protected market in Europe, where IBM against Siemens had a tough time breaking in because it was Siemens. And the customer stayed with Siemens and paid a premium to get a genuine Siemens product versus anything else. So they could do it.
But again, that's really not an OEM product.
Is just
Siemens is selling to the end user.
Directly to the end user and owning that market.
Yeah,
to their own market.
I'm thinking OEM in the sense you sell to
reseller.
Well, no, to a computer manufacturer other than IBM that doesn't have its own tape.
Yeah.
or you sell to a mini computer
Yeah.
manufacturer, or other systems manufacturers, including, where the system manufacturer
Yeah.
then integrates it into his system
the,
and
the
sells it
typical
to.
original OEM meaning of that never happened, and that would have been a difficult one to get. There weren't so many possibilities. Tech did their own stuff, digital equipment did their own things.
Well, Sun Micro, for example, might have been, I don't know, there have always been computer-based systems manufacturers who weren't willing to pay IBM $85,000 or $50,000 for a tape drive,
Yeah.
but didn't have the volume to justify the development, and that has been
Yeah.
a market.
The 3480 was too expensive for that one. You could have succeeded maybe to some extent at the IBM AS400, which was more a mid-range type product. That is 1 exabyte broke into that one. Quarterdeck to some extent.
Well, yeah, in fact, Exabyte produced a product, not the 3480 compatible, very
But
different.
It's a different one, yeah.
I mean,
The helical scan.
a VCR turned into a digital
thing,
recorder.
Yeah,
And they were very successful.
Yeah.
They sold a lot of OEM products to, even to IBM.
Yeah.
IBM ultimately offered the Exabyte
Yeah.
product.
yeah.
So there was an OEM
But
market.
that was much lower cost.
Yes.
That was for these ones. 3480 was also for big systems. That is mainframe. That is big Fortune 500 traditional big data centers. And it's the toughest market to break in. That's what Aspen tried to do. And they didn't succeed, and they couldn't succeed.
Okay, now the second generation then, you worked on the control unit, but that
And
was
the
not
tape.
for the first, was the control unit for the first generation?
No, the first generation, that was a control unit from IBM. And then the Aspen control unit, I didn't work on that one, but that didn't last very long. That was then immediately redone into the Summit tape drive, where we had the smaller tape drive, an integrated controller.
Okay, now we're on to the second generation Summit.
Yeah.
And was it substantially cost reduced from the
Yeah.
first production?
Oh yeah, it was by far lower cost. It was more a mid-range product than it was a mainframe product. It was that realization, we are not going to get into the big data center. We need something which could have succeeded at an AS400 because it was more compatible to what AS400 at that time. The only tape drive IBM had was a Telex 9-track tape drive. Big reel-to-reel, bit smaller than the original ones, but still a reel-to-reel tape drive made by Telex in Oklahoma. That's what IBM offered. That's why Exabyte could succeed in doing something more reasonable. 3480 could have succeeded in that one, yes.
But that's also the mini computer and server market,
Yeah.
which is more of an OEM.
Yeah.
The S400 is still a plug compatible end user market.
But to go into the server market, even the Summit tape drive was still too expensive. It needed something like an Exabyte, which was still orders of magnitude lower cost.
Even so.
Yeah.
Okay.
So then after the sale happened, after Aspen was sold to StorageTek, I didn't mind it a whole lot. I thought it was the best thing ever happening to Aspen because I thought that they're going out of business. We're not going to make it. But then things at StorageTek for me moved very slowly. I was moved to the fast pace, working a lot, making things working, that type of work. And then my boss at that time, Tony Meridian, we went to meetings and he was throwing bombs. I thought he wanted to get fired. He was very unhappy back at StorageTek. being back there. And StorageTek was just professional. We are here now. We are doing that. They said, okay, we need to do something different. We need to start our own operation. Let's do that. Let's get away from that and do that. They said, okay, go and find something. So then I looked through to see what I saw, and then in a magazine I found an ad from a company called Cipher Data in San Diego. They had a 3480 type tape drive that used the 3480 cartridge but wrote in an incompatible format. And they didn't sell any of those. You couldn't sell it. Nobody knew what it was. Oh, it's a 3480. No, it isn't. Well, what good is it? So we went to Cipher and saying, what you need to change your unit to make it 3480 compatible. And they said, okay, let's talk about that. So we went there and made them a proposal to do that for them. And it turned out then later on we used always the same type of structure when we did that. We made a bid for the whole thing. That's how much money we wanted to do the job. We will do it for that. Fixed bid. And you could make money with that, or you could lose your shirt if you had more problems than you thought, if it took longer than that. But we did that, and then from our standpoint, we wanted all the money up front. From the customer standpoint, he wants to pay when you're all done completely. So we compromised. We made a milestone schedule. That milestone, when we accomplish that, you pay us that much, and this one, you scheduled it out. Later, rather than writing down what the machine does, I defined the test we had to pass. It was much less ambiguous. And that worked out for, unless we're talking about Japanese, then that doesn't work. But for the Americans, that worked better. But for Cipher Data, we had a defined milestone schedule, and with a fixed bid, with a money amount on each milestone. And so we went off and did the 3480 for them. And it was, at that time, 6 from us. 6 of us left StorageTek. I think it was Tony Murdian. He was an analog guy, and he was my boss at that time. I was there. It was George Cummings. He did hardware. Baylor, he did analog. And Jack Marion, he was a mechanical guy and a head guy. We had to change the head, of course. And then we had CJ, she was a secretary and could do rework in the lab. That was our company. And we had Joe Freiberger to do machining in the machine shop. But he was he was part of our company, but we didn't keep him busy. So most of the time he was doing outside work type things.
On your machines, or his machines?
On our machines.
And the name of your company that you formed?
Mountain Engineering. Mountain Engineering.
Okay.
I don't have my business card.
Sure.
That was the name of our company, and we rented a space in Boulder, and then worked for the San Diego client.
Okay, so let me back up before we go into Cipher, because I'd like to explore why it was not compatible and what you had to do. But first, the controller you then worked on at Aspen, was it a copy of the IBM architecture? Was it your own architecture?
That was our own architecture. IBM and many other companies went through something called ANSI standard. It's a published standard which tells you the format on tape. Mm-hmm. It tells you what the tape itself looks like, the unrecorded tape, physical, magnetic characteristics, and then you explain the format. And we had regular meetings where we could go through, request changes, ask for clarification, what does that really mean, and that told you how to build a tape drive. It told you what the format had to look like. And it was fairly good. It was about 98%. IBM left a little bit left for you, so you didn't quite miss the fun of looking and finding it out yourself, what wasn't in the standard, but what you really needed to make it work. And you got to figure that out on your own, but it wasn't that bad. You had a good idea what was going on based on the ANSI standard. And the ANSI standard allowed all these companies to make tape drives. Otherwise, you can't do it. You never figure it out. It would take way too long, too much money. So that was our own design based on an ANSI standard. We implemented an ANSI standard, but then we also checked for IBM compatibility. If we got a tape which was outside the ANSI standard, it was, oh, well, does IBM read it? If IBM reads it, we had to read it too. If IBM doesn't read it, well, outside the standard, we didn't have to do anything.
So was it, at this point, the interface between the drive and the controller was digital?
Yeah, that was digital. The command interface was digital.
And the data interface?
In Summit, yes, it was digital. It was digitized right at the drive level. We sent over signals, but they were not processed. They were not de-skewed. They weren't...
You had to have a data separator to parse the bits out of the bit serial stream, which include phase noise. The bits were not phase synchronized, so you had 18 data separators in your controller
to do that.
Separating each of the 18 channels.
It was 18 tracks at that time.
18 channels, 18 tracks.
Yeah.
And then more later.
The drive sent over recovered raw bits.
Yes.
I got a bit of tape. Here it is. What the controller does, that's the controller thing.
It's technically, it's a channel bit. It is not yet a data bit.
Yeah. It's not data.
So your controller had the data separator, separators,
the phase lock loops for each track, the D-skew buffering, the error correction afterwards, and these things. That is
to produce 2 bytes of standardized data. Now the controller aspects of the microprocessor aspects of the controller you worked on.
Yeah.
Was that the same microprocessor as IBM used, or did you guys design it?
No, that was an entirely different one. You got your own processor. I forgot what we used at Aspen. We used different ones at different times. The language was originally all assembly language, and then later you went to some C.
Okay, that's the same story in the disk storage space. Assembly language to begin with.
And
for speed, and then you discover you could do it in C and write with a decent compiler, get the same performance.
You get the same performance, and you had 99% was written in C, and somewhere in a startup you had a little bit, a page or two of the assembly language, and maybe interrupt routine, which had to be fast. You wrote in assembly language.
These were commercial microprocessors.
Yes, absolutely. At this time, there were many around. You don't do your own microprocessors.
And it wasn't the same one that IBM used?
No. I'm sure it wasn't. We didn't even look what IBM used. We just, here's what we want to do, get the processor you need, look what's out there, and get a faster one to do it as fast as you can, reasonably. Guess what, the tools you need.
Who architected that controller? Was that you or somebody else in the group?
This was a group effort to do it. I did part of it. I didn't do the interface to the host. That I did not do that. I was always more on the drive side. The incoming data, what do you do with that? How do you do phase lock loop for each? How do you de-skew it? When do you clock it out? How do you have to do 4 to 5 bits translation? It was RLL code, runtimes limited. It's NERSI on the bit level.
Yes.
But then it was runtime limited to do it so you could clock each individual track. Okay. Otherwise you couldn't do that.
Yeah. So now you're for Mountain, you're contract engineering.
We do a contract development, fixed bit contract development, which in some cases is scary to do because you could lose your shirt. And the customer had one piece of it. That is a drive. And later we did that in other cases where the customer had a piece of the development, which helps to get the contract, which helps for the customer to hire you, because they have an involvement, they have an investment in their piece, they think they can recover part of that and contribute to it, and the engineers learn the product because the idea was always, we are not manufacturing, you do that. We may build 10, 20 units. But you're going to do the real manufacturing. We don't do that. One of our biggest fear when we started with Cipher was, what about if their part doesn't work? You cannot go to the customer and say, hey, your stuff doesn't work. That's a discussion you do not want to have with the client. So we thought, what do you do? But, well, you fix it. That's the only thing you can do, and we did. In couple of instances.
So tell me about Cipher. Why were they not compatible? It was 3480, but not compatible.
That's what they decided to build. They thought it was a good idea. 3480 is complex to do.
Yes.
They did not want to do the complexity. They said, here we get a cartridge from IBM, relatively low cost cartridge, because everybody was making tapes. There were maybe 5, 10 manufacturers of that chrome dioxide cartridge tape around. And they think, oh, that may be a good product with very little cost. We can build a drive. They had something previously that they worked on it, so they could make a transport for that drive. And then they had fairly simple electronics to write on that.
Was it 18 track?
No.
How many tracks?
I think it was 16. They had 16 track. It was entirely different format. I looked at it once and said, yeah, well.
Not an MR. Was it an MR head?
Yes, it was an MR head. The MR heads were around there. They used an MR head, and it came from a different product they had. Which also didn't do well. They changed that product into this one to use the new cartridge, 3480 cartridge. And they could not sell that unit, which is not really that surprising because it's not 3480. What you do with it? A new format.
It's an interesting question.
Yeah.
So it was a different head and a different number of tracks. So they just used the cartridge, but it was from a recording point of view, it just was off in its own space.
It is completely different. When I saw the ad for that, I thought they need our help.
But it could load and unload and wind the cartridge. It could wind the tape onto the proper mechanism. Move tape.
Yeah,
it may not have moved it as well as a 3480, but it moved it across a head.
Yeah, it was not a hydrostatic bearing, no air pressure involved. It had rollers. It's a roller-based system, which nothing wrong with that. It worked.
Some people might say a roller bearing system doesn't have the reliability, has wear problems compared to the
big ones,
air bearing.
But the world is now rollers. LTO is all rollers. Yeah.
Well,
that's what it is. Yeah.
The industry is replete with things you don't do, and then somebody does it.
Yeah.
In that time frame, I think the theory was, don't touch the tape, and it won't wear and will last a long time.
Yeah.
And that's true.
Yeah, but tapes got better, the overcoat got better, the DLC diamond-like coating on top of it, the lubrication got better. We used different materials to do that. Tape evolved too very fast. You can abuse tape to some extent.
Sure.
It's very forgiving.
Well, in fact, that was one of the accomplishments in the development of 3480. It is in and of itself, separate from the tape handling. In and of itself, it is far more robust than the 9-track tape that we had grown to love.
Yeah.
So, right. So they had chosen and you signed a contract to make it compatible.
Yeah, that was our job. Make it compatible, 2-year time frame we thought it would take, and that's about what it took.
And just, I mean, this is an example of one of the challenges in taking a contract. That they had to change the head of the tape drive.
Yeah,
They had to probably then change the recording, some of, even the electronics, very little as it is in the drive to
Yeah.
match the new head they bought from probably AMC.
Yeah, we took it out.
Yeah.
We took everything out. We left the servo controller in to
So
move,
to
to
move the
load,
tape.
thread,
You,
tape,
you left
and
the
move
roller
it.
system in,
Yeah,
but the head had to be,
a little mechanical change. The
Sure.
head was not that difficult to fit in. It was an AMC head, which we knew.
sure.
Same people.
Was it a problem getting them to change the head, or they knew they had to do that?
They knew that. They knew that they had to change the head. That's a different head. That was part of our job to put a compatible head in there and do the controller and do a SCSI at that time interface.
But you folks at Mountain did the controller,
Yes,
right?
that was all our part to the everything besides the loading, threading, and transport of the tape we did.
Oh, including the electronics in the drive to
Yeah.
go with the head.
Yeah,
Okay.
to the head, the preamps, the right drivers, the filtering, the analog parts, the digital part, the error correction, we all did that.
Because the error correction, the data synchronization, that's at the controller side. It's still
That is all
it's an
controller.
18-bit digital raw data, raw digital information coming out of the drive going to the controller.
No, there's no separate controller anymore at that point.
No, although it's an integrated.
It's all integrated, one board. At one end come the analog signals from the head. The other end is a SCSI host interface.
SCSI was the choice interface.
SCSI was a choice at that time. The whole world went SCSI. At Aspen, we had still what we call FIPS channel, the bus and tag from IBM. That is mainframe, big mainframes. The rest of the world, the servers, everything was running on SCSI.
Okay. So that's also an interesting early, if not first, integration of the controller in the drive.
Yeah,
I mean, traditionally, you had a very expensive controller, and you amortized it over a number of
drives.
expensive drives.
you attached 8 drives to one controller. Now it is one controller, one drive, one package.
Right.
That's what it was. We did that one
Was
board.
Cipher the first to go that route?
No, Summit had the controller and the drive were married also at Aspen.
Okay, so Summit,
That was a 1-1, 1-to-1.
one board also?
It was 2 boards.
Okay.
Well, but
Who cares?
at some point it is what's the drive, what's the controller. Yeah,
Right.
where we had.
Was Summit, Aspen Summit, the first to integrate?
I think so, unless StorageTek did the same thing.
But they were,
They were a little bit behind. I don't know
so
what they
it
did.
may have been the first.
To
to
my
prototype.
knowledge, we were the first one.
Okay.
And then we did the one at Cipher, and we had the size restriction. It was 8-inch form factor, that was that long. That was what the board, and we put all the electronics on it. And we had, you do this, and there was a piece left over which nobody wanted to do and knew how to do was an error correction. So I did what I always did, okay, I do it. So I started working on the error correction. I read through the patterns, and oh, that's actually not that bad to do. So I started doing error correction. 18 track first, and later we did the 36 track, which is different error correction. It's entirely different.
Yeah, the 18 to 16 error correction tended to be fairly easy to implement in hardware
Yeah,
because at the time hardware was very expensive.
yeah,
And
yeah.
fast forward 20 years, hardware is very cheap.
Cheap, yeah.
Microcoders are expensive.
Yeah, they have many more microcoders. When we started at Cipher, there was just a new development, and that was Xilinx coming along, where you could do the hardware in a chip, the programmable ASICs, and we used those. That was our first use of old big Xilinx 3000 series chip, which are long gone.
This
But-
was at Aspen?
As Cipher. When we
Cipher.
started at Cipher.
So that may have, in part, helped you get down to one board for the whole.
Oh yeah, otherwise you needed that much for the error correction. The summer took up that much. At Cipher I had that much to do it. And you can do it with the ASICs. The programmable one. There were a couple of companies who did that, but our choice was Xilinx, and they are the one who survived that. And they're still around here.
So was Cipher successful with your product?
Cipher was successful, and that could have been a very successful company. But then something happened. And that was Cipher went on a patent infringement case of a company called Archive. They made quarter-inch tapes. And Cipher won. And Cipher won at that $80 million in damages. 80 million, and that was in the early 90s. Today it would be over 100 million. Archive thought, we don't have that money. We would have to go in heavy debt to pay that. We have a different idea. Why don't we raise a little bit more money and buy Cipher? And they did. They bought Cipher for 120 million. Now we got everything. We got our products, we got Cipher products. We are going to be a big, strong company, and the whole thing is coming out to our advantage. Didn't work out like that. They got rid of the Cipher management structure because we were filing a patent lawsuit against them, get rid of those bastards. And Cipher was in a disarray for a while, until Archive tried to take them over, integrated it more, and merging companies isn't easy. And Archive had no idea how to do it. And they couldn't serve, then the sales went down, they couldn't service the debt, they went out of business. So because Cipher had a successful patent infringement lawsuit, both companies are gone. And I always said that is a lousy reason why a company goes out of business. I don't mind if you have bad products, you have no market, you go out of business. That's the way it works. You should go out of business. But because you win a patent infringement case, that was a bad reason. But that's what happened to Cipher.
So was the product though successful until the Cipher situation occurred?
Good, and which killed everything. All Cipher products, all Archive products, killed everything.
Did you have, your contracts have residuals?
No,
No.
no. It was always a fixed bid.
Fixed.
That's what you get each milestone. We get our payments, and that's how it worked.
So who are some of the other clients of Mountain you'd like to
Yeah.
share with us?
Yeah.
But by the way, from a cost point of view, had the Cipher, do you think the Cipher cost reached a point where it could have been successful?
It could have been successful, yes.
Or was it down to where it
Yeah.
could compete with the exabytes and the, at the
Not-
low end?
Not quite with exabyte, but it didn't quite have to, because it was compatible with the format of the big guys.
Sure.
It was 3480, 3490 compatible, and but it was by far more reasonable. You weren't in the 30,000, you weren't even in the 10,000. You could successfully sell it at the maybe 2,000, just below 2,000
Really?
range. You
I
could.
mean, that sort of implies a $1,200 manufacturing cost?
Yeah, you could do the $1,000 manufacturing cost, which a big part, the biggest part is your head.
Was
The head.
the head, of course.
The head.
Yeah,
That's-
I've heard prices of heads approaching $1,000.
That would be an LTO head, yes. The early LTO heads, we paid $1,000, yes. For the 18-track, what we had, it wasn't that expensive of AMC. Yeah, but it was still a big part of it. The rest was low-cost motors, low-cost electronics. There wasn't much in it to do it. There's a group photo I wanted to show that was taken of the Aspen Peripherals employees just around the time of the merger. I think it was before the merger, probably the year before, at the end of the year before, in the fall it looks like, in March, and most of them are there. That's as big as Aspen was about at the time of the merger.
And I understand in the photo in the lower left-hand corner, the young blonde male there is you, and directly in front, a little bit, is a woman who became your wife.
I met her at Aspen. I was never a fan of dating within the company. I thought it was too messy and too much gossip. People were very interested who was aligned with whom, and I never cared about it. I ignored all these things, but I always thought dating within the company, a small company like that, you shouldn't do it until Sheila showed up with her deep brown eyes, and there went my resolve. It was in March the merger happened, and we got married in December of '89, the same year after I dated maybe the 6 months around there. I left the company. My wife stayed with the StorageTek organization then for a few more months, and then she didn't want to do that anymore, so she went to CU and got a degree in international affairs and then one in psychology. She had fun with that.
You have children?
No, no children. We were both too old at that time. I was almost 40.
Okay.
A bit old. And we were doing the Cipher contract at that.
Right, we finished talking about the Cipher
contract, yeah.
And that was a 3480. Did you get
that was a 3480 format development for 3480 transport Cipher had. We used their transport, replaced all the electronics, including the head, and made it 3480 compatible. After we finished with that one, we were pretty busy. When you do a contract, everything is on time. You are busy, you're working a lot. I was doing the error correction, and the day in December, I had to get that problem fixed. And people want to push me out because I was getting married that evening. And there I was trying to fix that problem. But I made it in time to get married. So I left and made it there, saying, you really need to go now. So I left, did it. And all that contract work, we were young at that time, and it is tough work. It's very time-driven. Everything is on a schedule.
But then there are gaps, right? You contract finish, next contract is...
We were done with Cipher contract, and okay, what is next? So we start to look around. I went a lot to Comdex, a big computer show, and I looked for companies that had 9-track tape drives or anything else, tape drives, and said, don't you need a 3480 tape drive? And we talked to a company called Overland Data, and they got a bit interested, and then we didn't hear from them for a while, and we needed something to do, so we started to play a bit, saying, let's make another 3480 tape drive, but this time on a 5¼ form factor. Make it really small, and we thought we could do it with a cartridge sticking a little bit out when it's loaded, but get it into that form factor. It opens new revenues to the servers. We could put it directly into a server, integrated, if it fits there. But we did a prototype of that, and it was working okay. It wasn't 3480 read-write compatible, but we had the loading, threading, the transport. We could do that. So we probably need some money to do that. So we start to look around and saying, well, the VCs we knew was Carl Carmen, who had funded Aspen Peripherals. So we went to Carl, and Carl thought, yeah, maybe. What we can do, we have you develop that, and then we sell it to storage technology. I said, maybe. I was more thinking we sell it to the server market and become a big company and that. And while we were talking to them, Overland Data came back and said, we really want you to do that proposal. We want you to do a 3480. They had a 9-track tape drive, and they were slowly getting interested in libraries. They wanted to do automation. We need a 3480 type product tape drive to do automation for that. Why don't you join us? We do a contract and you work with us. And at the same time, we are talking to Carl Carmen. So I was talking to Tony, who just said, which one do you want to do? He was very much for Cipher. He didn't want to do the VCs. I was leaning towards the VC, but for a different reason. Carl Carmen and the guys thought we, of course, need somebody to watch these guys. You cannot just let them develop. Somebody needs to go to the board of directors, watch every step, make sure those guys stay on the right path to develop it in a reasonable time. And it needs to be somebody who knows tape drives. The person they came up with was Juan Rodriguez. So Juan started to talk to us, and I didn't know, I knew who he was, I didn't know him so much, and I was really impressed. That's why I want to do it. I want to work with this guy. I can learn so much. He knew things, how to manage people, how to do a company structure, how to sell. The technology was no question for him to understand. He was right there. I said, I really want to do that for that reason. Tony was for Overland. We decided to go with Overland. And it was, in hindsight, the right decision. So we went back to Carl, and Carl at that time had given us some money, I think 100,000 or so, to get us started. And we didn't have a contract yet with the VCs. It was just a preliminary letter of agreement saying, we give you some money and we will develop a contract, or at any time, if you don't want to do it, you pay us the money back and we are fine. So we went there with a $100,000 check and gave it to Carl, and Carl went, that's the first time that ever happened to me. When I actually want to fund somebody and they refuse my money, that hasn't happened. And then I heard one had decided not to do it, to be in charge of us. And the reason, he said, that I have been so many times at the other side of the VCs. I cannot do to you what these guys want me to do to you. I just can't do it. So they would have, and he got out, and I think he went to the university to teach something. He probably would remember. So it was a very short-lived thing with one, and since he wasn't involved, okay, said, let's do Cipher. Cipher was also in San Diego. And they said, well, you're in Colorado, we're in San Diego, you're a little bit of...
You're talking Overland now?
Yeah. Okay. Overland, I'm sorry. Overland was there, that they were in San Diego, and they thought it was a little bit far away for an independent unit to have there, and saying, why don't we merge? We want you to be part of Overland for a while. So I said, okay, fine. The merger was, we gave them all of our stock, and we got some of their stock. They were the bigger company, so it wasn't a one-to-one. So we had some of their stock, fine. And then we went and developed 3480, 3490, 3490E tape drive for Overland Data. They did some of the mechanical things, especially the integration into a library system. The guy who had started Overland, Marty Gray, was an engineering nerd type. He did not want to manage people. He did not want to be president. He did not want to be a manager. He wanted to sit in a corner and do technology things, and he got really involved. You could discuss technology with him. He was happy to do that. Anything else he put away. So the president was Bill Barden, who wanted to be a mechanical engineer, and he was a really good mechanical engineer. He did not want to be president, but he did because nobody else was around. And to their credit, they started to look for professional management, and later found Scott McClendon, who came from HP management. He wanted to do something new. He came to San Diego, he liked that, and took over that management, and that was a good, solid, professional management. So they did the right thing there. Bill Barden was an interesting guy. We went to his house, and he had 2 big cougar cats, that big, living in his house with him. And he built a house around with a courtyard in between where the cougar cats were. And we were sitting there eating dinner, and the cats jumping up looking where we were. And then he let them in, big guys with big teeth. He was a little bit unusual guy, but a really good mechanical engineer, and Overland became a fairly successful company in the library business. Meanwhile, they're gone. They couldn't compete against the bigger guys. There are very few independent library companies around for tape. About 3 years into it. What happened is after the 2 years we were over, we were done. It didn't make sense anymore that we were part of those guys. And so eventually I thought I need to say something. So I went to Overland, to Scott McClendon, and said, it doesn't make sense to you that you still pay our salary for that. We are not doing anything really, a little bit sustaining things. He said, yeah, I was thinking the same thing. But he was scared because a while before that, he came out to our place, and we had hired a couple more people who didn't know that well, who weren't into that mountain engineering thing. They were just employees. And one of the guys said, you're going to fire us sometime and go lay us up. And he said, no, I never do that. And his HR lady was with him, and you don't say that, especially not as a California company. So he was scared of a lawsuit that I never would sue you for something stupid like that. Let's do a friendly separation. He said, okay, what do you want? I want 2 things. We had gotten some stock during the merger, and some of the stock we vested. I want all our stocks vested immediately, and I want no restriction on sales if you go public. The idea was to go public, that I want to be able to sell. He said, okay, done.
Now, I have to say, I'm impressed that you as an engineer are making that sort of argument. That's a pretty good deal.
Yeah. From whom I learned it was John Squires. When I was at Aspen, I needed some stress relief, so I went to the YMCA doing weightlifts, and then I met John Squires there, and he worked at something called StorageTek, I forgot what it was, which was, the location was fairly close to where we were at Aspen. So each time at noon, I drove by to his place, picked him up, we went weightlifting together, and we went back.
John Squires founded CoData, which got acquired by Connor and became, but Connor had nothing, it was just a name.
Yeah.
So CoData became Connor Peripherals, which at one point was the fastest growing company in the history of American commerce, and then it flamed out. But John is an interesting fellow. I did his oral history a few years ago when I came to Boulder. So
that's how I know him. And I learned many things from him, just sitting in the car talking. And weightlifting, it's boring. You talk about things. And I got that from him. And I remembered him saying, yeah, you got to watch out for vesting of the stock. You got to make sure you can sell them, that you don't have to hold on for another 5 years while the VC sell all their shares and you end up with nothing at the end.
Well, at that point, I think you have negotiated a very good deal for yourself
Yeah.
and your colleagues. So continue your story.
Yeah, and then Overland wanted a couple pieces of the equipment we had in the lab, which all belonged to them. We were part of them. So I sent it and said, what about the rest of the stuff? The office furniture, all the rest. They're saying, oh, $500? Said, oh, I'll write a check immediately. So they sold it to me for $500, the rest of it. Then we talked to their lawyer and saying, we had a certain reputation as Mountain Engineering. Can we get the name back? He said, no, because we merged, it would be too complicated to do it. Change it a little bit. And said, to what? Said, well, Mountain Engineering 2. How does that sound? Said, okay, me too, we can do that. So that's how we became Mountain Engineering 2, because Mountain Engineering was owned by Overland. Then we were independent again, our own company again, with nothing to do. So we looked for the next job. And I did what I always did. I went back to Comdex and looked to find tape companies, and I found a little tiny company out of Boston. I forgot their name. They had a 9-track tape drive. Then people said, do you want to have a 3480? And he said, well, I'm way too small to even talk about that. But I did the 9-track tape drive with a Japanese company called Victor Data. They're part of JVC, a big conglomerate. And they were the old Victor Data company. The logo was still, if you remember, the dog sitting in front of that microphone thing, that is Victor Data. And they had tape drives, and they had a 9-track tape drive. So we started to talk to the Japanese about that, and ended up doing 3480, 3490, 3490E development for a Japanese company, Victor Data. They had, in their mind, only the Japanese market mattered. That's what they wanted it for. Take it and sell it in Japan. A protected market for them. Nobody else could go in, not IBM. There was Fujitsu, who had 9-track and 3480 type tape products, but he didn't think that was any issue. No, that they're selling here, I'm selling there. I said, okay, you got it. So we did that under another contract development, same thing, fixed bid, milestone payments, the whole thing again. After we had the products running in, I think it was, let me see, in 96. He said, well, you have the 9-track and the 3480 product, they're pretty good products we developed. Would you mind if we sell it in the United States? And the Japanese said, sure, why not? Knock yourself out. And we were still doing contract development at that time. So I said, we cannot have the same company selling things that do contract development. The client get immediately suspicious that their money funds our sales. So we started a new company called Mountain Peripherals to sell the products we developed and were manufactured in Japan by JVC. A little bit later, some company threatened to sue us because of the name, Mountain Peripherals. So we said, okay, we give in. That they changed the name to MP Tapes.
So backing up to the Overland product, again, buying heads from AMC.
At this time, it was still AMC who was still around at that time. They stopped making heads after that.
Okay. Again, you did essentially all of the electronics and all of the controller piece in a low-cost mechanism, same model as, this was an 8-inch or a 5 1/4?
That was 8-inch.
8-inch form factor still.
Including a big one of the brochures shows also the autoloader, a big cartridge autoloader.
A stack of cartridges vertically incrementing down, and and your price target or cost target, again, able to sell for $2,000?
No, we wouldn't sell it for that. You didn't have to. It was more like 5,000, 6,000. That's where you could sell it.
With the autoloader or just the basic drive?
That was a basic drive. With the autoloader, that was probably around 8.
So your still costs now are well above several $1,000s.
Yeah, yeah.
And that's actually up from your previous.
Well, that's where the Cipher was supposed to be a very low-cost model. When we, even with Overland, we said, no, don't do that. Build a bit, don't do that low cost. Build a better product, a stronger product. There is more price flexibility in it. You don't have to sell it down there and compromise these things. You never will compete with an exabyte, and you don't have to. It's a different technology, or the quarter-inch tape, or the real cheap things. You don't have to compete, and you can't really. You're compromising things.
And the difference between a very low cost, what are the compromises? In the tape handling, I mean, where do you compromise to get the cost out?
Mechanics,
Mechanics?
tape handling, tape path, speed,
Bigger servo motors, more powers.
reliability.
Well, but the reliability is inherent in things like the tape path. You get rid of pinch rollers.
Yeah, we got rid of the rollers. We put in the Overland and then in the VDS tape path hydrodynamic bearings. They didn't require the pump.
Self-loading bearings.
Self-loading bearings, the airflow carried by the tape builds a cushion. You fly over the things out of ceramic, the bearings. We did those for those which are more expensive. The tape is much more controlled, at least it was at that time, over the rollers. You didn't have the run-out, you didn't have the barber pulling, you didn't have many things what you had with the rollers. Much stabler tape movement.
Sure.
Much more expensive machine, but Overland was right. Don't go to the very cheap stuff. Then you don't want to compete there anyway. So we did that, and Overland had been selling that. And while we were doing that with VDS, Overland Data went public. And their valuation when they went public was 100 million. They raised about 30 million. We owned a good percentage of their stock. I was under no restriction to sell. I remember Scott McClendon calling some, please don't sell everything on the first day. You're depressing the price. Could you please tell everybody to wait just a little bit? Which we kind of did. I didn't want to dump everything I had on the first day. You can't do that anyway, so it was selling over time. I did that, and everybody else did. But they started out at $10. I watched the stock going up to the 15, close to 20, and was selling. And my friends at Overland Data were holding on to their stock, couldn't sell. And then it went from the high to the low, back to the 10s, to the 5s, to the 2, until they could sell. And that must be just devastating to watch the value of your stock go up. Now I have many millions, and now I have nothing anymore, and you can't sell. You couldn't do it. And we sold. It took me about maybe 6 months to a year to dump everything. So I cannot have my net worth tied up in a single company stock. I got to dump that stuff out, so I did.
Sounds like they did you a favor by asking you not to sell on the first day.
Yeah, I wouldn't have done it anyway. We were building a house, and I always needed more money at that time, so I called up that one broker and said, I want to sell some more, and he told me, you cannot expect to sell more than that many shares a day. If you want more than that, give me a week, and I sell it for you, but don't do it. They didn't want to depress the market to doing it, making an impact on it. So that worked out, and I told Tony, well, yeah, that was the right decision to do.
So jumping forward again,
Yeah.
You've done this product in Japan, and then imported it and sold it in the United States, and then split it into two companies.
Yeah.
To one selling the product that you had developed is being manufactured in Japan, and then continuing as a contract engineering group as Mountain Engineering 2.
True. Yeah, we were doing that with the data company until we were done with them. And it was about a 3-year time period to do it. And with lots of trips over to Japan, Yokohama area, we did a milestone, and I learned the Japanese way of doing milestones. I had done it before several times, and I thought I'm pretty good at that. So I came and said, here are good milestones. I said, no, hold on. No, you cannot do milestones like that. And I couldn't figure out what's wrong. So you write it. And they wrote up something, like, I don't even know what that says. What is it? So the guy finally, he couldn't talk to me. So he finally said, I want to have a drink tonight, come with me. So he went to a bar, he had a few drinks, pretended to be drunk. That gave him permission to talk, saying, you don't understand Japanese milestones. We never, ever miss a milestone. We can't do that. If I really would miss a milestone, I would have to write letters explaining the shame I brought on the group, apologizing all over the place. It's really not a good thing. I don't want to do that. So we write milestones. Then when the time is where we should make the milestones, we reinterpret what the milestone really meant. It meant to say we should be exactly where we are. We need flexibility to reinterpret it. Anything specific you write in, what about if you don't make it? It needs to be fussed up. So that's what they were doing. They're fussing up the milestone so they became meaningless. So you always made the milestone by reinterpreting what it meant.
Shoot the arrow to the wall and then draw the bullseye around it.
That method, yeah, that's a good analogy, yeah. That's how they did milestones.
So you agreed upon milestones?
Yeah, agreed upon milestones.
And you made them?
We made them, it's like, okay, and everybody was happy. And they are great in pretending. Everybody pretended not knowing what was going on, but everybody knew.
And did you hit the milestones as you defined them?
I probably would have missed a few because I wasn't used to the way the Japanese are doing business. It's a slower pace than here. At Siemens, the slower pace was because we test and test and test. In Japan, it was because we need, going forward, we need everybody's agreement. Nobody can take the responsibility to say yes to anything by themselves because other people may be impacted by that. We need all of their agreement, and then if it goes wrong, we share all the blame, which means nobody has it. That was a big deal for them. They all said, you guys have no face. You never fall on your face and get hurt. If something happens, you miss a milestone, so okay, we missed it, I'm 2 weeks late. Yeah. I try to do better, yeah. And it's no big deal. We miss milestones all the time at Aspen all over the place. Yeah, who hasn't? Because an unforeseen problem popped up.
That is quite uncommon in the United States in technology development and in many places to actually achieve your milestones. Everything is late and over budget.
Yeah, sure. That's normal.
80% is late and over budget.
And nobody holds it really against you. You will still get something done. It's there. You did what you were supposed to do. And we did that. So we did that with the Japanese, and it was a successful type thing to do. And meanwhile, we are still selling their 9-track and our 3480, 3490 products through MP tapes. And I wasn't really looking for anything else to do.
You said we are still, or you mean today you are still selling?
No, today not, no.
So
at the time when we were done with VDS, that was 98, 99, that was a time frame. Where we were finished developing, we were selling, and then the development was essentially over. We did a little bit follow-up work for VDS. Some things changed. With VDS, AMC had gone out of business making heads. So we took the StorageTek head We went to storage technology, took their head, and that worked out until storage technology decided the few thousand heads you are buying, VDS is buying, that's not worth it. We are shutting it also down. Give us the last time buy, so get that. Then we said, okay, we need an alternative to that. So we went to San Jose to IBM, and IBM said, sure, we sell you that head. That required a change in the electronics. The flex leads are different, the signals were somewhat different. So we did that change for VDS so they could use the IBM head. So we were going okay with that, and that was a little bit the follow-up work we did for them. Then a company called IntelliStore in Longmont contacted us. They were owned by Fujitsu, also in Japan, different location. They talked to us saying, we are the company, you did many tape drives, what about a DLT? I said, okay, I haven't thought about a DLT, but I can look into it. So I got the ANSI specs of DLT that existed at looked at the format, said, yeah, we can do a DLT, and I did a bit. And IntelliStore got out of the way, said you need to do it with our Japanese. They want to be in charge anyway. So I went back to Japan, to Fujitsu, and signed an agreement to do a DLT, transport tape drive for them. Meanwhile, I was on my own. Tony had died. He was a little bit older than I was. His wife got a brain tumor and died in a year, and then he went downhill fast and he died too. So I did it on my own. I did that one. We started developing the DLT drive, and then in 2000 the LTO committee started up advertising LTO. So Fujitsu said, can you change that, what you did, over to an LTO? Maybe we can leverage some of the things we did, but don't expect too much. So I looked at it and it was pretty much a start from the beginning. Yeah, you could use a little bit of the server. It's a different tape, it's a different format. Everything was different. And LTO was a great product. I always think LTO, they did many things right. I liked LTO. So said, yeah, we can do an LTO development. It's a standard, you join the standard, they give you the format. It's very doable. You have the head issue, but that is solvable. There were two sources, Seagate, because they were part of the consortium, decided to make the head. And then IBM, and I think we went with the IBM head. So we did that development for LTO1, the first generation of LTO. And that then took about 2 years. So from the previous 1 year worth of DLT development, Fujitsu didn't get much back. We were done developing. We hadn't been through certification yet. There were some pieces missing. Then I got a message. Fujitsu decided to go out of the tape business. I dropped everything, which was okay for the LTO development, a kind of bad. The good part, this one was, they also stopped delivering 3480 products and 3490 products. And besides us selling the JVC products, they were the only one. And we had a hard time competing against them. When they were gone, we were the only men standing, and our sales jumped up. The market was shrinking, but we now had 100% of it. So we were selling as many as 3480, never sold that many before. And it went on for another 3 years.
And these were sold to end users, or they sold to OEMs?
We sold no OEMs, we sold to distributors. Okay. And the tape drives, they didn't go into the data center market. They went into the peripheral market around there. Because
SCSI interface,
yeah.
and there were software out there that supported the SCSI interface.
interface.
So
And
there really was no, the traditional problems in the mainframe
no,
didn't
that was not
exist.
there.
But
Yeah.
it was SCSI that then
Yeah.
made the business.
The SCSI made the business, everybody could handle it. We sold to the people who do data conversion, to do copying, to processing for companies. All of those we sold.
So, but you were selling to end users now through distribution. I mean,
Through distribution, yeah.
you didn't have a direct sales force,
No,
But
we,
you-
we
but-
didn't want the sales force.
but you were selling through distributors to your customers.
Maybe 5 distributors who did most of it, and another 10 who did occasional one,
Sure.
where they could get a sale. They got it because they were in some specialty market type things. We sold that. We sold the seismic people, lots of those, and it was a pretty good time. And until IBM decided to stop making that head, and so we did a large, big end of life, one buy of IBM heads, which they manufactured, but we knew that was it. And so we shipped it until we done shipping.
How many heads did you buy?
At that time,
Yeah.
at the end of it, we bought 5,000.
And that was how many years sales? Another year?
Another year, just about a year.
Okay. So you're doing 5,000 units a year or thereabouts?
Yeah.
That's good business.
Oh, it was a good business. Yeah. But only because we were the only one. Our advantage was there wasn't any competition, and we never sold into the data centers, and IBM was as nice as they could be to us.
Well, you may have wound up in data centers, but by then the data centers were no longer big glass boxes. They
Yeah,
were,
yeah.
it was a different type of data center.
Yeah, and IBM didn't mind if we did 30 for 80 sales. They were long gone. They were into LTO, starting up at that time.
Okay.
So we had done the LTO development, and
No customer.
no customer and essentially no product. And meanwhile, our guys got older, and they're saying, we don't want to do that anymore. That contract development is a really tough thing to do. It is too schedule driven. We want to go up into beautiful mountains a day and do something. Said, okay, we need to do something different. So we started doing our own products. I'll just point out a couple. One of it is a 21-track tape drive, a reader only. It's in the 70s, Texas Instrument, built for the oil industry, a 21-track recorder on 1-inch tape, that wide. Many tapes were written. The machines were large, the big refrigerator-sized machines, everything analog, everything had to be adjusted. And when we start to look into it, when we got approached to do that, the estimate was that 10 to 15 of these machines around, and they cannot be shipped. Once you try to ship them, they are broken. It takes forever to adjust them. And many countries who have 21-track tapes, Bangladesh, Indonesia has lots, they will not let the tapes out of the country. You cannot ship them to read them. You got to go with their machine. So it was, can you build a 21-track reader? So we built one. And the question when you do tape drives, where does the head come from? But with the 21-track on 1-inch tape, you have a choice. We went to a company called World Magnetics. They do inductive head, hand-wound by a lady under microscope, 21-track with wire, hope that makes it. All 21 tracks are there at the end. Expensive, yeah, but it's a product you don't have any volume. You don't sell many. It was pretty clear. So you add in the margin. You have a margin there to do it. Then it comes in waves. We sell a few and then nothing. And then we sell again and nothing. I know when the sales start up again, we get 3, 4, 5 people inquiring. It goes all back to the same source when they all start up at the same time. It's an oil company want to read some tapes. They are in Bangladesh or somewhere. And there are lots of that 1-inch tape around. Sometimes people ask me, how long does tape last? I always thought that's the wrong question. The tape outlasts everything else. They have the 21-track tapes sitting there, being almost 40 years old. The tape is perfectly...
With iron oxide
yeah,
media.
yeah, of course.
So it's already rusted.
Yes, but rusted, yeah, you can, it's still there. The problem is, how do you read it? How do you get the data off? The machines that wrote it are gone. So we built that one, and so we read these tapes and we used a bit more modern technology.
So you're selling $100,000 tape drives again.
Right back where we were. And on the same bench at my lab, I have a 21-track tape drive sitting there. Next to it, an LTO-8, which I just got. And looked at it, the bit density on the 21-track is 3 bits per square millimeter. If I have to, I can put that visual powder on it, magnetization powder, go under my rework microscope, and I'll read the tape by hand.
Read it with a laser.
Yeah. So, and next to it is the LTO-8, the bit density on a square inch, and these are user bits. It's used encoding and then error correction is spreads out. It's 1 million per square millimeter of user bits. In written bits, by far more.
Would you mind taking a picture of those two machines and sending it to us so we can put it in the...
Yeah, sure, I can do that.
No,
yeah.
Absolutely. I think that's a tremendous part of your story, and it should be memorialized.
Yeah. It's a big difference. So the 21-track, it has no error correction whatsoever. It's a 9-track tape drive. Just they expanded it to 1 inch and made it 21-track because they added a clock, which was one of the good things to do. You don't have to speed adjust that much. You get a clock, written clock.
And so they wrote it with a clock, so it makes the data separation relatively simple.
It makes it possible.
Some skew, maybe.
Yeah, it's a skew problem you have with it. You cannot clock. You still cannot clock the individual tracks. The 21-track you can't. You have to clock it on a byte basis down there. So that is still an active product for us, but it's not our revenue product.
This is the Mountain Engineering 2 side.
Yeah. Our revenue comes from doing erasing of data, deleting data on tape, and LTO tape, and 3592. They're almost the same anyway.
Mountain Engineering or MP tapes?
Mountain Engineering does the engineering work, and MP does the sale of that. We don't sell the erasers. I looked into it and we can't sell that. Pretty soon everybody who wants to do it has one, and that's it, I'm done. There are no follow-on sales after the first one ever. It's not the market. So I came up with a different concept. We rent out the machine on a usage basis. You tell us how many tapes you want to do. We send you the machine. We tell the machine how many to do. It counts it down. When it's done, it stops. It tells you before where you are. You call us up saying, I want to do 1,000 more. We send you a short encrypted string. You download it into the drive, and it goes up and does another 1,000, adds to whatever you had left over, and you are ready again. We invoice you. And we have 3 or 4 sites where they keep the machine permanently because they're doing enough business. And just tell us, we need more licenses, we call licenses, we send them more licenses, we invoice. And some go to on-site, do it at the customer side to do it. And they do whatever the customer needs to do, the 5, 6, 10,000, and then they're done. They send the machines back.
Now, when you erase LTO, are you destroying the LTO?
No.
No.
That is easy to do with destruction. You get a degausser. There
Degausser,
exist
right.
many, and you can buy them for a few dollars a
So
thousand.
you are erasing the data but not leaving the positioning information
The server
untouched.
bands are intact, so you can reuse them. There are two reasons companies do that. One, they change technology, the tapes become available, they want to sell it on the market. There is a secondary market for used tapes. You get a bit of price deduction, you're about maybe 80% of a new tape to a good used tape, which is quite a bit. The other ones are within an enterprise. Big banks, companies find out this branch is buying LTO5 tapes. We are destroying LTO5 tapes because we are going to 6 or 7. It could be a tremendous savings if we move the tapes down there. The lawyer said, in no way can the data move. If something happens, it's my job. It's important that that not happen. If you erase it, yes, now you can do it. So they're using these to erase that.
And then they can ship them out.
Then they ship the tapes out. So we are doing that for all tape generations for the LTO tapes. And that is where our revenue comes from. Side effect of that one, important side effect. LTO did many things right. One of the things they really did right is they took the Sony concept of a secondary auxiliary storage inside the cartridge. Sony called it MIC, memory in cartridge. LTO calls it CM, cartridge memory. It's an RFID interface to a small chip sitting inside the cartridge. The drive writes performance-related data in it. How many bytes transferred, what the error rates were, several error rates, history of the last 4 mounts, things like that. There are now over 200 performance-related informations in that chip. Our equipment reads that chip out. It needs to know which generation tape drive it's dealing with, what tape it is, and so it reads all that information. We bundle it all up, we give a report to the customer. The equipment does the reporting for the customer, how many tapes he erased, what the tapes were, the serial numbers of the tapes, all these things, and we gather that information. And in some cases, we can get that information. Not all customers allow it. There is nothing customer-related whatsoever in that data, but the customer doesn't necessarily know that and trust us with that, but most do. So we get that information. So now we have over 1 million, I don't quite know the number, by far over 1 million performance data of used LTO tapes in the field. And a while ago, I started to mine that a bit, to look what does the data tell us. Now we don't have that many manufacturers anymore, but in the older days, yeah, exactly. We had like 5 or so, and I could see how is each of them performing. Are there difference in the performance between LTO generations? And it's interesting, thanks. Statistically, I cannot claim the data are significant because I didn't select it randomly where we get the data from. It's a group which wants to erase tapes, and they could be clustered, they could not be. It's little ones and big guys doing it. It's all over the place. And it's the number we have, it's about 0.5% of the shipped cartridges, not the installed one. Installed would be higher, but I don't have that number. The shipped cartridges is easy to figure out because the LTO committee releases that information and tells us how many cartridges have shipped. At least I did it in the previous year. Then the sales went down, so they start reporting shipped capacity. Capacity goes up, tapes go down, they start reporting shipped capacity. You can backtrack it out of it. So you have to do that math. And then you get your shipped cartridges out. So I looked and we had around 0.5%. It's a little bit older number, but it's about that of that. That gives me a nice overview over how is tape performing in the field.
That's incredibly good data. I mean,
yeah,
I think it's, with that percentage, it's got to be statistically significant. But
Yeah, I won't claim it because you really have to, in order to do it, from the school, you have to select the group, it has to be random, and I did nothing with that. I take what I get. It comes to me here, so I take it and put it in. Each time we send out new licenses, I send out the records, I add it to it, and we do that. And that is ongoing, and our peak is currently on the erasing is still LTO4 cartridges. LTO5 is picking up pretty strongly. 1 is dead, 2 is just about dead. 3 is still going, but they're still in use. 4 is heavy, 5 is heavy, and we see very little of 6, nothing of 7. Of course, no 8s, they are not even in the field yet, really.
Can you share with me some observation from the data?
That always gets a bit difficult. I have to be a bit more careful. I don't want to say which vendor was on top when, but in general, tape is really reliable. It is, there are 200 different parameters in it. How do you quantify it, bring it down to a reasonable number? We have another product which we made in MP tape cells called VeriTape. It's just a small box. You put a tape on it, it reads the RFID chip and gives you a score value for that cartridge from 0 to 100, 100 being really good, 0 being absolutely bad, and we assign some colors to it to make it easy. And we have an algorithm that crunches all that data and gives you the number. But that algorithm was developed for a specific purpose, and that was to throw out bad tapes. And the message to us was always, if we eliminate some marginal tapes in order not to get a bad tape in, that's okay. A bad tape getting in is very bad, so be critical. So we have that really tough algorithm on it. And that told me there are about 2% of the tapes that are bad overall. And that is really good. And some of the bad tapes may be very usable still.
And that's data from these, is that running your algorithm against the machines that you erased? You look at them and you say, well, you get the score.
Yeah, we do the score. We do that for what we erase, but we also have, it's a different product. It's not an eraser. Sure. It's that VeriTape product. It's just a small box, that big.
But it tells the customer whether a tape is good or bad. Do you get that information back here somehow? Is it Wi-Fi connected? Or?
No. From that we get, we mostly get the data we get back is mostly from the erasing business. Yeah. From the VeriTape business, we get some back where somebody does a whole library. I want to scan, I have many problems, there are problems. Problems happen. I want to see all the tapes. I got to get rid of the bad tapes. They scan every single tape through, and then sometimes they send us the data and say, here, what do you think? And typically it is, yeah, you have the few bad tapes, throw them out. And they happily do that and see it. The other interesting thing we see from the erase tape, about 8 to 10% of the tapes have never been used. They're sitting in a library, the picker never got to them, they are there. They're getting rid of the entire library. They are brand new tapes and we erase them.
So are you still doing, so you're no longer doing contract engineering?
Almost none.
Yeah.
We did a project a while ago with Imagine. That was, when did we do, let me just take a peek. That was in 2004. We had done a previous project which Imagine, which was a government-funded development project. The government does that, the Department of Commerce, I think, funded one thing, where they pay you half of your development cost if you do something new and exciting. So we went together with Imagine. Imagine knew how to do that government-funded study things, and they got 2-3 universities participating. That was always important to get the funding. You have to have the university. Carnegie Mellon was in it, and yeah, those guys, and then Ohio State, Bushon, he did lots of mechanical stuff here,
This was some sort of new, unique tape format?
Just basic tape technology. Everybody did what they wanted. We were working with a company to do ceramic air bearings.
Okay.
Then it worked to some extent. We did that, but then imagine had an idea. That we want to take a small disk drive and put it into a tape cartridge. And said, why would you want to do that? The idea was, well, it was an idea. They're saying, we sell it as an easy way to increase the performance. You have a library and you need an intermediate cache where you need the quick access versus a long storage, and you do it in a 3480 or in a LTO type cartridge. First they wanted to do DLT, then they decided LTO. You put it in there, you load it in, you read the disk out, and on the interface you pretend it's a tape.
So
Yeah.
you create a head type, you create a magnetic interface.
Yeah, you create a magnetic interface to
And
that thing.
you run the disk drive on batteries?
No, you powered the disk drive through the loading mechanism. You come down and
So it has some electrical contacts.
yeah, we had a small docking station, this 5¼ inch form factor, so it fit in the library. You load the cartridge in, put it down, and we had what's called pogo pins, spring-loaded pins. You go down directly to the contact of the disk drive. I think you had 5 pins, something like that. And it is a SATA type interface, which is serial data, clock, and the rest are the voltages. The 3-4 voltages, and then you select the ones you need and you put it on and off you go. And you did that. I said, okay, fine. We can do that, yeah. So we quoted them, we did it, and they said, we also want you to build them some. Okay, so we had an agreement with Imation to build and sell them, I think 300 or 400 of those.
Really?
So we did.
So this is it's a unique drive, though. It doesn't read regular cartridges. It just reads this cartridge.
Just this.
So it's not even a tape interface, it's an electrical interface.
It's an electrical interface, which to the library looks like a tape
The
interface.
controller,
The
it's a SCSI interface responding to the SCSI tape
yeah.
commands.
It emulates the whole drive interface.
Sure.
To the library. The whole thing looks to the library as a tape drive. The docking station looks like a tape drive. The cartridge looks like a tape cartridge. All it knows it's a tape cartridge. That was the sales point. Easy implementation. You don't need to do anything.
But the rewind speed is
yeah,
infinite.
Fantastic, and everything is great.
And
yeah.
the read speed is whatever data rate you'll take.
Yeah. And you can still have your tapes there, and for the quick access, you don't have to go through this appliance and put a disk in and do that. You just do it that. And I saw some validity in it. We did it. Yeah. And then we shipped the 400 to Imation. I think they gave 2 away for testing. The sale was 0. The rest of the drives went into a warehouse. And then they at some point decided we had enough, we destroyed them. I said, no, don't do that. Sell it back to me. I bought them back for a fraction of the cost, for just about nothing, all of those, and sold them all to the government for a legacy problem. A department, branch of the Department of Defense had. They have a system that expects a 9-track tape drive on the other end. They are gone. They are under directive, they cannot be used, has to be new. There are no new 9-track tape drives. So why can't you change the host that it expects now an LTO? That wasn't possible. Then don't ask, okay? That's the message, I guess. Don't ask, it's not possible. Said, okay, fine. We sold them to Ulysses, that's what we call these cartridges. And since it had a tape drive interface, to emulate a 9-track was nothing. We take a few lines of 9-track from the 9-track tape project codes, put it in. Now we pretend that this is a 9-track tape drive, and through a SCSI interface, we say we are a 9-track tape drive, and their system believes us. I'm talking to a 9-track tape drive, they're talking to this Ulysses product,
Sure.
and I could have sold more, but I'm not manufacturing. It would be too expensive to start that up. I'm not doing that, but I sold every single one again.
Okay.
That worked out. So we are doing that, and then we do one more thing that I shut up about our stuff. There are very few independent library companies around anymore. They all went away. There's IBM still doing libraries, and Oracle is getting out of it. They're getting rid of all this old StorageTek stuff. 2 weeks ago, they went from 80 people in that division down to 40. There's almost nobody left. And they said they would get rid of all hardware. And then HP does their thing, and the only independent one left is Spectra Logic here in Longmont, Boulder, between Boulder and Longmont on the diagonal. And when they sell a library, they sell media. That's what the library companies always do, the first sell at least. And most say, yeah, you get a pretty good deal when you buy our media with the library. And Molly Rechter, who was the marketing lady, said, no, we don't sell media at a discount, we sell it as a premium because it's better than anybody else's. And they start doing it, and she could pull it off. So she sold tapes which were better than everybody else to there. And then the question came, what exactly makes your tape better? You're not making it, you're buying it from there. Why is it better? And then Nathan, who runs the company, said, could you clean the tapes? There is slitting debris on it, manufacturing debris, can you take it off? So I said, yeah, sure, we can take it off. So we built them a tape cleaner. And they run every cartridge they buy through the cleaner and put it in the library loads it in, the cleaner cleans it, and then they resell it at a premium. So we do tape cleaning. That was not quite a contract development, but they paid us for the development, and we sell them the cleaners for that. And we sell a few outside the library market, but not that many, typically in catastrophic situations where somebody decides to build drywall inside the library or next to the library and it's dust all over and all the tapes are contaminated, then we do that. And these are our products. And with our products, we can pretty much do what we want to do. It's not that schedule driven, it's not that stressful, and you can take life a little bit slower and easier.
Make those walks in the mountain when you want to.
Yeah, well, I cannot tell this my wife, so she would say, now you are saying you can leave whenever you want, let's do it. It doesn't quite work like that. You still stay busy with things.
Sure. So, is anybody who is making this, who is designing this tape drives today?
Tape drives, nobody is IBM. The tape drive, the tape technology started with IBM, and it's ending with IBM.
Is IBM even designing tape drives? They're not doing it in Tucson.
Yeah, it was NEC who did the tape drives, the LTO tape drives for IBM. And they're still doing it. Tucson helped NEC.
Oh, Tucson still has a active research team.
Yeah.
Which is researching the technology, the media, and the heads.
Yeah.
And they may actually be manufacturing someplace in Eastern Europe, Hungary or Austria. It's not clear. There's rumor, but
NEC was doing it first in Japan, and then they went to China. I wouldn't be surprised if they manufacture Eastern Europe. Now HP was doing it. They were manufacturing Hungary. But HP got out of it.
HP is out of it now.
Yeah, HP is out.
Yeah. StorageTek is out.
StorageTek is out.
You're out.
We are out.
You were one of the last. You were one of the last four.
We were one of the last men standing. The only tape drive you do is a 21 track. Right. Which doesn't count, okay?
It counts, but it's not.
Yeah, it's not new development. IBM is the only one. It started with IBM and it ends with IBM, and nobody else will get in it. The entry fee is really high. For somebody to cold start and saying we are now doing LTO 9, 10, no, won't happen.
Well, there are two tape manufacturers only.
Just barely. After they decided to go after each other with a vengeance over patent infringement. One of them can currently not deliver LTO 7 to the US market.
So we're down to 1.5 tape manufacturers.
1.5 tape manufacturers.
One tape drive developer.
Yes.
Maybe.
Maybe.
And that's a scary place for the industry to be.
It's a scary place to be. It's all when if IBM decides they don't want to do it anymore, that's it. They still do some research. They did the research in Switzerland on servo tracks.
Yeah, they have an active program in Switzerland.
Yeah.
And in Tucson. But
Tucson,
it's pure research.
Yeah, that is the research, and NEC is doing the manufacturing, the implementation, and Gordon is his name, the guy is running it. I talked to him, yeah, he's a good guy, it's a good company, NEC doing
NEC?
that. Yeah.
So NEC may be and they're really doing the development of the drive. I mean,
They're doing the development with IBM's input help, yeah. They did the Jaguar, they did the LTOs.
So maybe NEC could possibly, as IBM gets less interested, if NEC sees it as a good business. I mean, it's still, what, a couple 100,000 drives a year?
Yeah.
At $10,000, $20,000 a year? A drive?
Yeah.
On a
quite what you pay. The library, most drives go into libraries.
Okay.
The library companies typically don't pay quite as much. It's more like 5.
5? So 200,000 times 5
Yes.
is a large number.
Yeah. NEC could maybe, if they want to, is a different issue. It's for them is a small piece, like the media for one of the media companies. That's not what the company is all about. Yeah. I doubt if the president knows he's doing LTO media. He said he's in entertainment and stuff.
Actually, maybe the bigger question is who's making heads? Who's designing heads?
Yeah. Nobody, IBM. IBM, that's it.
They still make the heads, though, I believe.
Yeah, sure, they have to.
They are still a head manufacturer.
They're still a head manufacturer.
And they sell them
heads.
OEM to anybody who wants to make a drive.
I bet they would.
I think they do.
I don't think they have a customer.
Well, maybe it's NEC. Unless
Yeah,
NEC
well,
makes
but
heads.
yeah, NEC, that's it. Yeah, but that's the IBM drives.
Yeah. So it sounds like you think the tape industry is
It's
going away.
It's narrowing down. I don't think it's going to go away that soon. It has a certain amount of momentum, and the cost of storage on tape is still by far the lowest. If new technologies like flash and other solid state wipe out the technology, it's going to be disk before tape. Because disk is more expensive, it acts more like a disk, it is more like there's still an order of magnitude difference to tape. Cost storage, it's tens of cents a gigabyte on tape. Nobody else can touch it, so that will be around. Tape is a strictly archival media. Nobody does the processing anymore, nobody does the data interchange anymore through tape. There are other ways of doing that. It's just the archival, and the archival still has to happen.
And therefore the low-end, lower level drive has no market, because if you're going to archive, you definitely don't want to put your archival tape on a drive and have it eat it.
No, you don't want to have it eaten, you don't want to have the technology not exist anymore. You go to external disk drive, or you go to the cloud. If you have little data, if you are a professional office, a doctor, a dentist who has the data that goes to the cloud. He doesn't have a little tape drive sitting there anywhere, and he shouldn't. Go to the cloud, eventually goes to tape, the cloud gets backed up to tape.
Archived to tape.
Archived, yeah, so it ends up on tape, so there is a place for tape. And I hope that IBM agrees and keep on going. They agreed to LTO 10, up to the roadmap goes to 10. Of course, they could change that, but I believe they will go to 10. What happens after LTO, I don't know. Our erasing business certainly will continue. We are erasing now LTO 4s and maybe 5s. We are years behind. By the time we get to erase LTO 10s, I'm going to be 100 years old.
Well, that was a major, in the early days of tape up until really DLT and LTO, traditionally the new device, actually up to the 3480, the new device always read the old.
Yeah.
The 6250s read the 1600s, they read the 800s.
Yeah.
The 9-tracks read the 7s.
Yeah.
Then they stopped. Now it's just 2 generations. So if you're doing LTO 8, you've got to worry about your 6s.
You've got to do the migration.
You've got to migrate.
You've got to migrate.
Creates your erasure business. So you're right, that's going to be a business for
it keeps on going. Yeah, you got to migrate, and data migration is really important, as the guys who have 21 track tapes found out. Yes,
Yep.
You should have migrated many years ago.
Well, in fact, the same situation exists in videotape.
Yeah.
But in videotape, interesting, there's an active business in making heads for the old Ampex recorders.
Okay.
Because they can't migrate unless they want to digitize.
Yeah.
So they have to keep reading the old and writing the old video tapes. And so there's a industry of folks who make new or refurbish the video heads for those early Ampex video recorders.
Yeah.
Different way of, instead of migrating, they just
do it that way. Yeah, but for LTO, you got to migrate. You got to migrate your data, and the big guys certainly do it. I see lots of
sure.
them.
So it's every
2 generations.
Every 2 generations.
They tend to skip a generation.
Sure.
Unless something entirely new comes along, which was with LTFS, and that became available, they went immediately to it without skipping a generation. But if it is like it is with 8, or it's a capacity increase, then you skip a generation.
Yeah, which makes good business for your erasure business.
Oh yeah, the erasing business is a business that runs by itself. When a new generation comes along, we don't need to do much to adapt our technology. And we have a tape transport, of course, to do that. You need to move tape in order to erase it. So we needed a reliable transport. So what I did, we took an IBM LTO drive, a down level one, not the newest one. LTO 4 I can buy for less than $100. Take their electronics out, put our electronics in, and have a very reliable product where the whole mechanism cost me less than $100. And I get all that great IBM quality for that amount of money to do the erasing. That's how we do the cleaning too. I know I could develop a reasonably reliable product transport for that amount of money and manufacture it.
Okay.
So that was our business model. Just take an LTO, down level LTO, new ones. I can buy LTO 4s $100 and do the conversion. Takes a few minutes. Just pop their boards out, pop ours in. We are compatible, fits right in, and we are up and running.